Hopefully we get it wrong again. It's foolproof. It's not wrong.
Oh yeah, because like if it's like 2. Oh wait. Wait, this is big brain idea. So if there is a quadratic, I can just move it down to be 2 linear factors because it's literally better.
Oh, let's go to sleep.
Wait, yeah. If it's a quadratic that cannot be factored, I can move it down to just be a square because that's a worst case. Ooh, that's a big brain idea. So now I've got it down to all linears. Now every factor is real. Made every factor real. That's great. Then what do I do after that? I need to prove that somehow I can find a point.
Why are you guys so retarded? Stop.
So I have. Do I have any number of factors on the real line? I need to prove that I can get a point where it's at least distances to them is at least at least 1 or something. Or like at least anything. At least anything is good.
Right, you're claiming you solved it.
Yeah, at least anything.
So,
What do you mean not really? Do you even know? I don't like people who kind of just go with confidence and don't actually know what's going on.
With an odd number, you can rearrange it so there's 1, there's 3 at the top and like 2 there. So then you can move these 2 up, move those 2 up, and then put it into the top one.
Oh. Okay.
So basically you can either end up with, at the top you either end up with a 3 and then you just move all the 2's into it. And you end up with a 1 and 2 2's and just move the 2's into the 1 and all the other like 2's into the Z as well.
Because otherwise it's literally. Alright, that's actually.
So you're saying that works for odd?
Yes, so any odd number you use one of these
very
2
nice idea.
ways and it works.
I put
For even numbers it seems to only work if it's a multiple of 4.
Okay.
Now it sounds like a pigeonhole principle. I ain't gonna lie.
So
Now it sounds like pigeonhole.
if it's a multiple of like 2, that's not a multiple of 4. So this just put like if we put this middle one to be the one where we want to put all our frogs,
Now
then
we can kind of make sense.
if we this one will take only 1 to move there, so those 2 can move there. This one will take 2 to move there, so it can move with this one. But this one will take 3.
Basically the number of moves to get everything into there is odd. Because it's 1 1, 2 2, and then there's a 3. So and if the number of moves to get it into there, like the total is odd, and doesn't work.
So you can't.
No, so because this won't work because it takes 1 move, so that's even, because 2 odds. And this is even, so it's even. This one's odd. So make sure the whole number of moves odd.
You're saying it's impossible to do a 6?
Yeah.
So that's
Because you always end up like having 5 frogs and then 1 frog.
okay. So how do you do with multiples of 4?
The multiples of 4, you just group them all into 2's.
Let's see. Okay, so you seem to have something for odd and multiples of 4.
Yeah.
And then you prove that 2 mod 4 doesn't work?
That was supposed to be the 2, 4, 5, 6.
Yeah, basically.
Or only
Like
6?
not only 6, like every single like even number which is not a multiple of 4.
Every single number.
Like every even which is not a multiple of 4.
Because like so the
You always
next
end up having
the
like a
next
big
one
number
is
and then 1 next to it and you can't like do that.
the next one after 6 is like 10, so you have like 4 things, but so and then they'll all add up to be even, so the total will still be odd.
The total is the
Like
The total number of moves. Basically, if you just move 1 at a time, the total number of moves to get everything to one thing. The 6 is odd, which means it's not gonna work.
Okay. It's an interesting idea. Can you carry out the proof?
Okay. We'll work on the proof then.
Have you done C1? Have you done C1?
Can't.
What are you doing on your phone?
Oh, I'm going to decide to do 225 to decide to do C4 instead.
Oh.
What?
Join the live stream.
Odd numbers right now. I'm working with any two of the basic scripts. Different processes. Oh shit. It's a counting problem. Then. Processing scripts. So we take views. Oh shit, this is screw. So that's what you can't have. Wait. Can you really? You stay on the same one.
Recording in progress.
Where's the remote? See a TV remote? Yeah, okay, so there seems to be at least some pretty good progress with C1. People saying that if n is equal to a multiple of 4, or it's odd, then it can be done. But claiming that if it's 2 mod 4, it cannot be done. You know? For odd ones, you're saying something like, so you have, so that's like an odd number of things, and then you're saying that you can kind of move these up like that. That's what you're saying, right? Okay, and when it's a multiple of 4, your idea is to kind of like, so there's an even number of pairs, and so you kind of form these pairs, and then you have 2n pairs or 2m pairs, and then you kind of, each pair just kind of moves as a single unit, and then they all end up in one spot. That's what you did, right? Okay, good. And then your idea when n is 2 mod 4 was that for them to all end up on the same pad, it required, did you say an odd number of moves? An odd number of sort of single jumps, but obviously your moves consist of an even number of jumps.
But I think it was like it requires an even number of jumps, but there's an odd.
It's an odd number of jumps. Now I'm confused. I thought frogs were jumping in. What?
That's pretty. That's a pretty cool book. Which one are you looking at? Yeah, it's not like that.
Wait, so you have like 6 pads, right?
Choose one to be.
So you're saying like if you make them all try to get there, right?
Yeah, well, log you can.
That'll take like 1,
um,
2,
day.
3, 4, 5, 6, 7, and then 8, 9, 10, 11, right?
And if they're in a cycle, so you can go like that way as well.
Yeah, but
So it
6 is
doesn't
even.
change it.
No, once you show that there is a way with the odd, all methods have to be odd. Because it's an even number of moves, right? So the parity of each individual move, the amount of times it takes to reach that one goal remains the same no matter how you move it.
What is he saying? What? Okay.
Because there's an even number of things, right? The parity has to reach that one point. No matter how you move it, the parity remains the same.
Hmm.
And thus, if there is one odd number of ways, all have to be odd. So if you can do it in an odd number of ways, the only way to complete it is an odd number of moves, proving that.
I guess you made some claims. I don't know if you proved that.
Ooh. He has claimed things. What about these claims?
So you're basically saying like to get from point A to point B, the parity is fixed, you know?
Yeah. Because, say, there's a point which they all reach, right?
Hmm.
So draw some even number of circles, right?
Even number of circles.
Even number of like lily pads. Oh, that's 2 mod 4.
Two
Okay.
more out. I thought you meant
Let's do.
just even.
So, picking any arbitrary lily pad doesn't matter. It's the same as picking any other lily pad because it's symmetrical. We'll say it's this lily pad,
Okay.
right? Now, this one takes 1 move to get here. Because it's even, obviously going around the other way takes 1 move as well.
Mod 2.
Mod 2, yeah.
Okay.
Yeah. And if you ever go back and repeat moves, the amount of things you took would be a multiple of 2 if you return to it lily pad.
Hmm. Okay.
And because it's a multiple of 2, and both of these have the same parity,
Mm-hmm.
and changing something by a multiple of 2 keeps the parity the same.
Hmm.
The parity of each one must remain the same no matter how you move it. So if you can show it takes an odd number of moves to reach 1 point, it has to over all combinations of moves.
Hmm.
Okay.
And you can show it takes there's a combination that takes an odd number of moves just by going in a move for each one. So 1, 1, 2, 2, and then it's an odd number, so 3. So it takes an odd number of moves.
Is that what you did? Is that what you did?
Yeah, it's like even minus odd is odd, then even minus even is it. So, same thing.
Hmm.
Odd is great.
Yeah, basically the same one.
Okay.
Yep.
Yeah, I guess that's pretty clear. Might be a bit tough to prove if you really got down to it, but
To make it easier to prove, I use the coloring. Oh,
And color like,
now I don't need the weird mod.
so you have like white and black on the circle.
Yeah. When you're white and black with the 2 mod 4, you have the odd number on the white and the odd number on the black.
Ah,
And when you move 2, you preserve the parity of the number on the white and the black. I think. Yeah, it's basically equivalent.
yeah. I think that's actually different, right? Like because one of them you're showing that the parity of the moves don't change, right?
Yeah.
But the other one is you're showing that the parity of the positions, the total number of odd positions don't change. I think that one's more obviously true. See, because you can keep track of one move, right? Like that's just 2 adjacents. But if you want to keep track of one that goes around and back, it's kind of a bit annoying. So yeah. So if you color the dots white and black, right? Then every move, there's only really like like two cases to consider, right? Moving the same color or the different color. And either way, like the number of things. Right. So what happens if you have like if you have a white and a black, the white goes to the black goes to the white, right? You have 2 blacks, they both go to the whites, you know. So the total number of white and black occupants don't change parity.
Yeah.
You know, like that's a much more obvious statement to prove. That's a more like that's a proof. Whereas, saying that the move from A to B is the parity doesn't change. That's true too.
What's
But-
this the parity?
But the explanation is not quite the same, you know. Okay, so I guess that's C1 done, you know. Do you guys understand that? You guys don't understand that. Excellent.
There is no real. Isn't that ridiculous? Why is there geometry? Like you go from G1, which is basically trivial, to G5, which is impossible, and then this
quad bash instant.
C1 to C6, there's not that much of a difficulty spike. Like C6 isn't ridiculously much harder.
Yeah, they don't know how to balance the questions.
Yeah. Although according to
Recording stopped.
this is so geometry just gets impossible, whilst this doesn't get much harder. At least for C6.
So I'm just hating the geometry.
Are we doing geometry today?
Yeah, a bit.
Are we
Did you do ones yesterday? Did you look at the problems on Discord? Oh yeah.
Okay, are we doing physics, maths, or something today?
Physics.
Yeah, like at 4 o'clock.
Whoa.
Physics, maths.
We're doing physics. That's what
Because we have the physics.
Oh, can you stay? Can you stay to 6? Oh,
Because we have the phys cam person comes.
C2 is also a pretty cool problem. What about C3?
C4 seems not
So there's a set of all 9-digit numbers. Which is what's the probability choice as a multiple of 11? What's the divisibility rule for 11?
Yeah. That's just once you have it, that
I forgot. Was it like the odd digits minus the?
Yeah,
Oh.
something. It's one of.
Oh yeah, cause
Yeah.
like 10 is minus 1, whatever. Okay, that makes sense. Okay, yeah, it is the odd digits. Now what do I do? What do I do now? Probability that a knowledge isn't around the best. That's pretty ridiculous. How do you do that? That's crazy. That's crazy. C3 is ridiculous.
I'm joining your stream now, stuff.
Oh, good. Oh, Slava, are you in the stream?
Slava can't join because it's failed that.
What?
No.
Even on your laptop?
Oh, I didn't want to take my laptop.
Holiday man. Holiday man.
When I need Wi-Fi now.
Do the number
Yeah, we have
randomly
Wi-Fi.
choose 11. That one sounds pretty tough. Ooh. Sounds pretty
I
tough
should bring my
right now.
laptop as well, so I can get double views.
All these only 7 Google accounts.
So you're considering it's going only up to 9.
It's like, so the Wi-Fi is like Netgear 97.
Isn't the password like something violet or tulip or something?
It's like Shiny Violet 370.
What's 1 plus 2 plus 9? That's 45. That's 1 more than 45.
If someone wanted to, they could now find your Wi-Fi password.
You can find where you live.
No,
Yeah. Oh, wait, you can just do it on the website.
No, you can play Roblox as well, so oh my god.
It's like another way to stream snipe.
Streams. Snipe the streamer.
You don't have enough viewers, and I don't think your viewers are dedicated enough to do that stuff.
Ooh.
It's on your mental
Low.
1 more than 11.
One more than let me just see.
What about? Okay, 1 more than 11. What can it be split into? What's 1 more than 11 divided by 2? To 6 more.
Are you guys doing C3?
I'm doing C3.
Wait, what's the status of C2 for the
I should probably start
David?
I
trying.
think I did C3. Come on, retarded. The probability that 4 numbers chosen from 1 to 6 adds up to 6. I mean, I could theoretically plan. Like, I theoretically could bash out C3. That would be cancer. No. Yeah, I could bash out C3 very easily. But no bash is too hard. Yeah, what do I do? It's like
Plus or minus signs.
That's pretty hard. Without that. Bruh. Do I just have to case back all the like, well, not naively, using the power of recursion?
But is C2 induction?
Maybe. You could, I don't know, it's probably a way to do it. Some other shit. Can you do it? Yeah, I don't know what I'm doing. This induction.
Oh. C2.
Yeah. What did I get about C4 is this hexagons of side length, but then they say area less than 1 on 1500. It's like, it's base times high, so surely it's not rational.
C4 is some fucked Oh, sorry.
Hey,
Oh,
yo,
Michael's
some-
gonna get
what
demonetized now.
is
Oh, no.
Michael's gonna get
assume
demonetized.
position? But you avoided it. You gotta.
Oh. C4 is some torturous global question. But global questions and me just don't agree. I can't do them for some reason. Just the one type of combi I cannot do at all.
It's amazing. You have like a new excuse for every question. Like it's like tailored to that question. It's like I just can't do questions where there's like set A B C D E F P1 P2 dot dot dot
Yeah, I just can't.
P2
do-
250. I just can't do those kind of questions.
Yeah, I just can't do the questions where you like consider the set of all S of all nitrogen numbers in which each digit is used exactly once. What is the probability that other number is randomly from S to possible to
Those questions.
Those questions, man, they're just too hard.
Especially when there's a
I
blue
just don't-
C3 next to it on the left. Just
Yeah, I was like,
on the left.
this question.
I did C2. C2 is actually a decent problem.
Too cool.
Yeah.
But it sounds like AMC.
It
So people
sounds
like
like
the
a type of
problems
like
they can do.
just choose and such bash question, but it's not.
C2 just looks like AMC questions.
It looks like an AMC or annoying like kind of AIMO like question.
Yeah, except AMC would replace it with like a flag consists of like 50. Okay, no, not that many, but like something that fits into. I don't know.
Yeah. It's like an AI 5 or 6 kind of thing. It looks like that. It's actually a nice question.
Yeah, it's just like AMC questions for 26 to 30.
Wait, has everyone done 2?
No. Doing. Damn.
Oh, you finally got in.
This kid is. Oh, good job. Sir will be proud of you if you do that.
Yeah. I know, for some reason, the accounts are like 10 of them.
Your what account?
Speaking accounts, 10 of them.
Trying to get your Bing account still.
Man's got 10 accounts.
He's got 10 Bing accounts.
Yeah.
I feel like there's some kind of other community strike I can get from something like this. It's like,
No, I don't think you can. Yeah, Liam.
I mean, if someone else bots your account, it's not yours.
Yeah, exactly. You know, you're not.
Technically, I'm not bossing. I'm watching it on every single one of my accounts just to get maximum information. Because the more accounts, the more information. So I get 5 times 60. 5 times 0 is 0.
C3. How do you do without that?
Where? Oh, that's different.
What do I do? Probability that they might have chosen random.
You said do that. This is
It's Google alarm.
Yeah, for AA, I have some funny ideas.
AA.
AA.
No.
So, like, you know how the real polynomial, or at least the monic real polynomial, like
Yeah.
product of linear and quadratic factor.
Okay.
So,
Quadratic.
so how do you deal with the quadratic? That's the question. Well, you see, the quadratic parts you can decrease to a square. Because the quadratic factors that you can't factor into,
Yeah.
they're like basically they're like they're strictly greater than 0.
Okay.
That's the quadratic.
You have 9 viewers
So
currently.
basically what that means,
It's crazy. That's not even. That's more than the people who view it.
what that means is that
Yeah.
if you perturb the
How many
polynomial,
accounts are you
So that
watching, Slava?
it becomes a linear.
I'm just
So like
using my
you
friend's
decrease
account.
that quadratic factor to become like
Really only
touching
get one
0, I suppose.
So you have 3 Slavas watching.
It's like he's
right
making up for all the other days he couldn't get on. By
now.
triply.
He's getting as many Slavas as he can.
Yeah, like if you
Yes,
decrease the quadratic factor to like that, then you can have the linear factors.
Linear factors.
But the question is, why can you do this? Well, because you're decreasing everything. If you're kind of perturbing
a
it
bunch of incognito
so that
browsers.
if this polynomial still works, then the original one will work because it's strictly the absolute value is strictly, well, not strictly, but like greater than or equal to this one.
Is this Discord linked to this? Oh, it's not.
So you're saying you can remove all the quadratic factors?
Yeah, I'm saying I can decrease the quadratic factors. So like we'll log that there are no quadratic factors.
There are no quadratic factors.
And then for the linear factors, because they're just all roots that are real. So now we're all real roots.
Oh.
I guess will log that the roots are within -2 to 2. Because otherwise they would also be further off if they weren't within that range. If you were to try and take a point within -2 to 2 and try and prove it's greater than or equal to 2. So it's like, and we'll log a bunch of things, but like now I need to do some insane crap where I prove this is at least 2 or some point. It's like
Automatically. This language we automatically translate.
It doesn't matter, I'm just gonna set everything to Arabic.
I'm just a farming
Arabic's not even there here.
Now they're just changing their Google browser to Arabic.
No, that's why friends browser not mine.
How much longer will he be your friend
Oh,
for?
he said it never offered to translate these languages Arabic. Okay, I'm getting rid of that.
God. How many viewers do you have now, sir?
8.
Very nice, very nice. Slava, get more of your...
Yeah, well, probably just make
Be on
some
my way
more
to
accounts.
farm.
No, here's the strat. Create a bunch of guest browsers.
Wait, also his session keeps yapping now.
So, come on.
Wait.
Create a bunch of guest browsers.
Okay, thank you.
Yo.
I can see this. Good luck dealing with that.
Create a bunch of new guests.
Amazing.
Nebula.
And then go...
Just like imagine naming Nebula to school.
Imagine being named Dragon Striker Assorted Number.
Oh, that's not my username.
No,
I guess
Nebula
it's like
is such a good username.
I don't understand why.
Who thinks Nebula is a bad username? No. No. Alex thinks it's bad. Rest are irrelevant. But Alex thinks it's bad. No.
It was just busy with viewers.
C3.
Like it.
What the hell?
Okay, Simon.
It's actually kind of hard. Unless there's some insane, like, multi-reaction. I would not hold high hopes for a problem that the AMT has published. So,
It's not their problem, you know what I'm saying?
cause like, because I remember the ASC. So yeah, the problems are a little bit scuffed. They probably stole all of these, like.
No, it's not working.
Well, yeah, I guess it wouldn't be called stole if they just cited the source, but they don't.
Yeah.
But just because they're doing to scare people or some such, because somehow someone...
No, if they cited the
Yeah,
source,
but
it would be
decided
like.
that, from
No, if they cited the source, it would be like Egmo Q6, and everyone's like, what?
Okay, I got another.
No, everyone would be like, oh, Egmo, that's...
I mean, there are reasons for like not citing the source. Like, for example, like people could just look up the solution or something. But like, you know,
But
if I wanted to
the
find
source
this-
was still found. So.
If you wanted
Yeah.
a solution to a problem, you could post it on like mods or
Yeah.
like the Otis Discord server, and someone would give you a solution.
Yeah,
very
someone-
quickly.
yeah, I think
Whoever
it's
says,
still
like, oh, damn,
it's
I
still
see
better
that.
to like just kind of rely on people's integrity and have your own integrity and
If someone
Write the
actually wanted to
source.
find it, like the mods Discord server, you can get a solution to any of these pretty quickly.
yeah.
And Otis is way overkill for all but the last get solutions.
Michael, I am 33% of your viewers.
Really. Oh,
How many viewers do you have?
they apparently have 9 viewers now.
Yeah, I'm 3 of them.
Makes up for the other times you couldn't get in.
Yeah.
Wait, Slava, use other browsers. Open some Safari windows.
No, the guest windows don't work. They don't count as views.
For real?
Yeah.
But why?
But you know what? I was just like,
Create more Google accounts.
I will.
Bro.
You literally read my mind.
Wait, did you get C3, Alex?
No.
It's such a...
Well, I don't know how to do it without bashing. I can bash it, but
It's very bashable, but like... Ugh, such a stone problem.
bruh.
Creating
I'm just thinking like there might be some multi-dip something. I don't know. Oh.
Google doesn't like the website. Oh, bro, I was born in 1901.
What?
Google would just let me say that I was born in 1901.
What? I suppose, you know how the AMT seems to not be able to rate Combi at all? Suppose that seems to be a pattern.
Maybe that's why AC
Nah, because according to, like, I read somewhere...
Maybe that's why like last year.
Something Evan Chen said, there are just a bunch of like ridiculously hard ISL C4s that are like harder than C8s because people can't rate Combi.
Mm.
Oh, there's this USA TSTST this year. They put question 3 level difficulty as question 1.
Oh, what?
Because what happened was, so it was really easily fake solvable, and all the problem raiders fake solved it.
Oh man.
Except the person who suggested it fake solved it, realized they fake solved it, and then thought it was still easy. But it turns out it was like problem 3 difficulty, and it got like less solves than like most of the other questions. Like less solves than like problem 3s and
how
6s.
are you getting problem
Michael,
testers who are like big solving everything? Nah, that's not acceptable.
Wait, how many viewers do you have now?
8. I am 50% of Michael's viewers now.
50%?
Yeah, I've got 4 accounts.
But why I have less
Something
than...
is wrong with
It's
the
10,
open-
it's 10.
People
It
left.
says 10.
What, it's 10 now?
There's this person
Oh,
on
well, now
Otis
only
who's like
40%. I guess I'm
description.
Yeah, I'm 10%.
Oh, I guess we're gonna make one.
Oh yeah, let us know when you get C2 or something. Have you tried it for small values of n?
Look at this guy on the Otis Discord server. Read his about me.
What's monk? We already.
I don't know what monk is, but like the rest of it's kind of questionable.
Roy has something against that.
He seems to have
The man hates math.
Who?
Nah, there's this guy on the Otis Discord who's about me is
I don't know if he hates math.
look. I don't think he hates math. He just hates the mass contest community. It seems. But literally, this is
I
his
guess
about
that's
me.
like bad.
I hate you all.
And then it's yeah.
Oh, well, I mean, it's not unreasonable. I mean, grinding, if you're just purely grinding, and it's kind of toxic. I remember, I guess back in the day now, there was a little bit of beef between 2 students. And I was like, basically, it was just like over a girl at Matt's camp or something. And then like the
Oh, no, I need to do my
What?
phone number.
I'm not beefing with anyone over a girl.
and then there was this complaint that like
You were.
no one wanted to help each other because they were all competing against each other.
That's a good point.
It's kind of toxic.
Yeah, I like, because like the thing is when I hear about people saying, "Oh, wow, the Math Olympiad community," it's so like the people you meet are wonderful and you form many friendships throughout the years. I'm like, okay, but I'm literally directly competing with. How do I?
Yeah, like I feel like there's some
I don't know.
events are very unnatural. Like having the lectures before the TSTs is just so unnatural. Like, how can you sit there and listen to the lectures that you like probably already know? And like, there's a test on like tomorrow that will determine like.
There are some people who are just grinding way too hard and value Mass Olympiad way too much. Like that person who I showed you, supposedly it said they were in year
do so
9,
much Math Olympiad.
and then he said they'll quit contest math if they don't make mock this year.
Damn.
Yeah, I think there's a lot of also like parent influence as well.
No, I don't think it's even
Seems like
parent.
I'm on steroids.
Like in Australia, it's probably not that bad because making senior camp, like most people could probably do that.
I don't-
But like in America, like making senior camp is basically equivalent to making US AMO. Like what? Fuck, 250 people selected out of 300 million in America is basically equivalent level to select.
I don't know if senior camp is trivial in Australia.
Yeah, but getting senior camp in Australia is the equivalent to getting like US AMO.
Getting used.
Like,
I guess he's saying it's doable,
yeah,
or is he saying it's not doable in the US?
like making mop in the US, I don't know. It's like it's a lot harder. It's still doable, but like doable, no, it's significantly more difficult. Because what? Yeah.
Michael.
What?
I'm a 71% of your viewers. There's a 7 people and I've got 5 accounts.
Wait, why is it only 7 now?
Michael, if not for me, there would only be 2.
How did everyone quit? Is it just automatic lagged out, timed out?
Yeah, if not for me, Michael would only have 2 viewers right now.
Yeah, which would you
I don't know, like in junior camp,
this isn't 9 watching.
if you're just
Oh,
in
yeah,
junior
yeah,
camp, you're not really competing, or at least I'm not competing with really anyone in junior camp right now, because they're all.
I mean, what about the year 10s?
Yeah, what about the year 10 juniors? You know,
Don't forget the year 10 juniors.
There's probably like a maximum of like 3 or 4 juniors who are actually I'm going to be competing with.
I don't know about that.
Not
I don't know
that
about that.
Like me!
I'm not sure about that, dude.
Yeah,
There's probably plenty of juniors who are in the run, because the AI was like, because you basically can't get into the first time.
True.
yeah. I don't really understand what you're competing for. Like, there's nothing to compete
Yeah, exactly. The only time you should
for.
actually.
You should just like literally just make friends and learn that. So there's
Yeah,
not
exactly.
really anything more complicated than that.
Here's
Yeah.
my great strategy to maximize what I get out from junior camp. Make friends and grind Otis. Because grinding Otis is probably more worthwhile than doing the actual junior camp.
Yeah, but like if you get super paranoid and start just kind of like being suspicious of people, you'll probably end up doing worse and the thing you feared in the first place, you know. Because you're wasting too much effort on something very minor.
Like what?
Huh?
Huh?
I don't know, just kind of like just be honest and intellectual, you know, you don't have to
Yeah.
be, I don't know, strategic in that kind of socially strategic or whatever.
Socially speaking.
What's
I feel like that's a common theme in like, I don't know, either Pineapple Island or just Canada.
Yeah, I mean, like a lot of these cultures are just images of like parents.
But what's the thing with? I think it's not just parents, because I think at some point a lot of the students just want to win. Like I don't know, unless
They
they're
do.
not competitive.
What's going
But
on?
like, I don't know, winning something you value. Like you want to win, don't you? Don't most people just want to win above all?
Yeah, but like, you know, like your parents can either be like, "Oh, you're absolutely right. That's exactly what you have to do, 100%." Or you could be like, or they could be like, "Oh wait, no, you're doing this for education. Like the achievement isn't really, you know, like."
Yep.
Just because they didn't say anything also doesn't mean like.
Wait, so what's going on with people being strategically social on Pineapple Island?
What?
Well,
I
Alex
feel
said
like you're
something
drawing
about that.
conclusions.
No, that's what Alex said people were doing on.
Why are you saying stuff like that? That's what. Shit. No, be quiet. That's not what he said. Stop misquoting people
What
and
did you
naming.
say about Pineapple Island?
That's a common theme.
Does Pineapple Island have a lot of like juniors like basically worshipping seniors or something?
I don't know. How do I? Wait, actually, C3 is hard.
I feel like C3 you're just meant to bash.
Like, I can do it in the AMC way. I don't know how to do it in the not bashing. Because it just sounds like cancer.
But I said hello, sir, to you.
Yeah, I said hello back.
Oh, thank you, sir. It's very respectful of you.
All I can say hello in 5 accounts.
I have to
Every
say,
8 likes and my
having a lot of juniors in Australia is actually a good thing. I think probably helps reduce the like competitiveness.
What?
Or
How's that work?
in America, it will be a lot more. Think about it.
Get it.
What
You
does
have-
competitive even mean?
So then, I mean,
I think there'll be a lot more pressure, and you need to try harder to do well in America.
Pressure.
I don't know how to explain. Like
I don't get pressure.
when you have if you get
Pressure's
in the
like
USA,
pressure's like if you have like the expectation of getting in, and then
yeah,
but it's not like obvious that you can execute on the exam or something. That's like pressure.
yeah, a lot of people I think in America would have that. Because like
Oh, that doesn't really make sense because
getting into America's
there's still
junior
only that
camp,
many people that should expect to get in.
But getting into America's junior camp is harder than getting into Australia's senior camp by a lot.
No, I don't necessarily think that's true.
Because what?
what do you need to get into junior camp?
Because America's junior camp's like red mop, I think.
What do you need to qualify?
I mean, just how many people get into that?
Yeah.
I don't think what he's saying.
Scores.
That's not relevant.
The cutoff scores are in 2020 were.
You're kind of annoying. Stop talking.
Alright, I'm sorry.
C4 is quite confusing.
It's just doing like 5 problems at once.
Uh,
Hit that boy's playing 5 games of chess at once.
boom.
It's like how Slot is watching 5.
Hmm. 2 to 5. Hmm. Pretty ridiculous. Really. Let's try.
Wait, Liam, can you explain to me how you did 2?
C2.
Without everyone else hearing?
Without
Obviously, first one would be black, white, right? There's only 2 possible.
without everyone else. Yeah.
And then
So,
black. This is black, white, grey, right?
Mhm.
Black and white. So then it'll be white, grey, grey, black. Next one, all black. Right? Literally, so half of them have to be grey. Half of them not. There's an odds from the form of black. Right? Even on half of them. You get what? Because on all of them. On the next thing, all half of them are grey. You have to go to the black.
Great. What are you talking about? So let's do like 3. There's like 5 spots.
Yeah.
What are we doing?
Look at the top combinations and like 5.
This is an empty spot.
5. Yeah. 5 would be. And
Hmm.
It's like 1238. I think it's like 1003.
Powers of 3.
It's like, yeah, I just flowchart chart. Then like,
Whoa. Whoa.
it's like, this goes back right here. This is really flowchart.
Are you just doing like black first? Or
It's like, you see, this is black, white, anyway. It's
So how's the flowchart work?
So,
Invest?
it's the first stripe, second stripe, third stripe. Two little possibilities.
Okay.
Black.
True.
Then, so
The gray comes in the odd spots. Yeah.
this thing repeats, so you can go in this like, this thing also repeats here. And this thing should have the same number of possibilities because you can swap black and white and it works. So yeah, you have to be able to transfer those five so this one was not a possibility before, or it's not a possibility now. A little white so it's 127. And then you can also do this in surround and buy a fresh option. Have the same possibilities of this thing.
Do you have an actual answer as well? The number?
Mine like deductively determines it based on the last one.
But you should be able to like turn the recurrence into the.
It's like 2, 4, 6, 4.
I'm now curious what your solutions are because. Alright, so your job is to explain to me your solutions. Because something is sus.
Michael, how do you only have 5 viewers?
Oh no.
And all of them are me. Michael only has 5 viewers and all of them are me.
I want it as well.
Recording in progress.
I want that.
Alright, so you're telling me you solved C2, so what did you do?
You want me to
Okay,
explain
I
mine?
went off to watch me now.
So say for an arbitrary odd one, you have
I would like to understand it for a small case, you know?
no. Mine works basically inductively.
Okay, so you're doing stripes like the way, is it vertical stripes?
Vertical.
What are you doing? So something like the first one has to be black or white, is that what you're saying?
Yeah, first one has to be black or white.
That's,
And the next
that's
one,
true.
because the next one you can determine from that, so you get black,
So it's white or black, is that what you're saying?
no, white,
Oh, wait,
grey,
no,
grey.
sorry.
If you were to count the number of combinations, white, grey, black.
White.
Just
So it could be white.
grey, and black. You have 2 possible.
Right, how are you doing this? So it's white or grey. Okay, it can't. Wait, that's one. It can't be grey, right?
Yeah. No, it can be. There's 2.
But the third one is gonna be grey.
The odd number ones cannot be grey.
Oh, cannot be grey. Okay.
Yeah. It's white, grey.
So, how you say? So if it is black, the next one could be white or grey.
Hmm.
And if it's white, the next one can be black or grey.
Yeah. So that gives you 4 combinations, right? And the
Right.
next one, it's 1.5 times that because half of them are grey.
So it could be black and white. What?
Half of them are grey, so. And only the grey ones have 2. So it's multiplying by 1.5.
Multiplying by 1.5.
Yeah. Because half of them are grey, right? So for that grey half, each of those there's 2 possible outcomes. Plus for the rest there's 1. So it's, and because half of them are grey, it's 1.5.
Okay. And then what's next?
What's the most confusing shit ever?
The next one,
Let me
it's,
Yeah.
let me think about it.
the The next one is times 2, right? Because
He's
all of them
saying
have
that.
2 outcomes.
Half of them are. So you're saying that this one goes.
So no
It
matter
has to be
what,
black.
Odd always has.
Okay.
After an odd, on the next move, half of the combinations result in a grey flag for the even. Half of them have a black or a white flag. Because on an odd, all of them are black or white.
It's like a bi-direction.
Yeah, so half of them have to go to grey, and the rest go to black and white. So that means on any arbitrary odd, it multiplies the previous even by 1.5, and on an even, it multiplies the odd by 2. So it's like...
so you're saying the answer is like 2 times 2 times 1.5 times 2.
Yeah.
And so on.
Yeah.
Yeah, I think there's a slight issue with Liam mocking proofs.
Yeah.
You cannot construct a proof that you cannot.
So are these all independent?
Are they independent? That is the question.
So you have like a grey.
You can induct that they're independent as well. Because if you assume for an n that all the results previous n minus 1 flags are independent upon this pattern, then the next one has to be independent, right? Because
What does that mean?
Yeah.
for each of the ones that multiplies by 2, because the previous one is independent of every other one, and they're all independent as well.
I feel like sometimes you say stuff and it just doesn't really stick. I feel like you just say stuff you like to say. Like it has nothing to do with this idea of proving this problem. It's like I said the word independent because we're like trying to multiply stuff, and then you're just like, oh, independent sounds very cool. Independent. That's it. It does seem like a pretty good idea though. Hold on. So
I think I can turn this into a proof.
can other people turn this into a proof?
I could totally do it. Let me think. How do I turn this into a proof? I say what? Yeah, I think I can turn it into.
Wait, so your idea is kind of the same, right?
Yeah, except I just wrote out more stuff.
Yeah. Okay. Let's go with David's.
Like, it should be the same thing, but like I think I got the same answer. So
Yeah, I'll make it horizontal stripes. Okay, so you're saying the first one could be like.
yeah, I'll just do black because like you can replace all the blacks with whites and they're the
Take
same.
that away.
Okay, yeah.
So we
Just times by 2.
Yeah. So we have black, and then you get white and grey, right?
Okay, so it'll be white or grey. Yeah.
And then from white and grey you get black. You get the black from white, and then black and white again from grey.
So you get black here,
Black and white.
like that, right?
Yeah, and from the blacks, both of them give white and grey, and then the white gives black and grey.
So your legs don't ever get
And then from the white and grey you get from the 2 white and greys you get 2 black whites, and then from the black and grey you get white black white.
On the what?
on the
Alright,
bus.
so you
There's like
get
a small Indian mama child.
white and grey, you get
Smaller than
black.
some-
And then here it's black, white. Yeah.
Yeah, and then this do the same thing.
Yeah.
I think it's white, black, white. Wait, this is black and grey.
This is black and grey. Oh, yeah. Oh, this is white and black.
So basically, this one loops back to here. This one also loops back to here.
Oh,
And then this one should also give the same number of possibilities if you change the blacks and the whites around. So
oh,
yeah, so basically this step is just like a times 3.
hmm.
Right.
Oh,
And then
huh.
Can go to line, but the white can go to the gray.
Oh,
Yep.
that's very interesting. Now you guys says there's repeats.
yeah,
Okay, so whatever numbers are there, just
Yeah.
times by 3. Huh.
How do you do secret? Well, I tried, but it's not that. It's not immediate. How do you do see-through? It sounds so impossible to do without backing up. The bash probably isn't that bad.
C4. How do we do C4?
Because it's not just there are more the triangles divide the area into.
Wait, Alarm, do you get this? Do you know how to get the number from this? So what number is it? There's a lot more 2s than 1.5s.
So 1.5 times the 2.
So I think it's like, for n is odd, it's like number of possibilities is 3 to the power of n times 2.
Okay, so when n is odd, 3 to the n times 2.
Oh wait, no, so if
3
n
to
is
n,
if n
that's
is
more
in the
than-
form of 2n plus 1. 2x plus 1, so
2k plus 1 is 3 to k
yeah.
times 2.
Wait, so n is 2k plus 1, and you're saying it's 3 to the k plus times 2.
Yeah. And then if it's in the form of it's 2 to k, then it's 2 to the k minus 1 times 4. Right, 3 to the k.
3 to k.
3 to the k
Minus 1. Yeah.
times 4.
That seems to be consistent with the Liam. Yeah. So if Liam did that, he would be able to do it. Except I'm basic one. I spent this. I had only 1 and 2. and I was like mod 4 or some shit. Like 2, 3, 3. Okay, so I just wouldn't get it if I go. Question 3 sucks. 8. Oh no.
We try C4. Actually, looks interesting.
Huh?
C4.
I feel like I haven't seen like an actual proof written down for C2 yet from you guys. So we're getting there because we now have a statement. Yeah. And this actually looks like some working.
How to prove that this is true? Maybe we can use the Liam's idea.
Liam can prove his own idea.
Well, are you trying to prove that they're all independent?
Right. So.
What? Because I think that Liam's idea has actually pretty good
Potential.
Right, so is it the same as this thing? Do you agree?
It agrees with this.
Okay, so I got the 2 because the first one could be black and white, right?
2. And then
And then what? Liam.
Yeah.
And then what?
What? Then what? What?
Okay, so then your next step was to say multiply by 1.5.
I think it's multiplied by 2 after this.
So after the first one, it's multiplied by 2, 1.5, 2, 1.
So it's 2 first. It's 2.
So it's 2, 1.5, 2,
Yeah.
Yeah.
and 1.5.
Yep.
Yeah. So just agree with the equation. Or we can try dividing the equations. So we have the 2k, the 2k plus 1. Do we divide them to get? You get 3 divided by 2. That's true. That's 1.5. None. But what if you have the 2k and the 2k minus? And you switch them.
Okay, so from B to WG, you're timesing by 2 because it's 2 possibilities.
2k plus 1 and 2.
White and grey.
Then you get
What are you doing on your phone? Give me your phone.
I'll stop using my.
Alright, so you're timesing by 2 here because it's white and grey.
Yeah.
Okay, and then why are you timesing by 1.5 here?
Because half of the above are grey.
Half of the above are grey.
Half of them are
What does that
grey.
I
mean?
can prove that
Half
that's
of
true.
them are not grey.
Yeah. For an arbitrary
Oh, I hate it when he starts this crap.
Can you just hear me out? For an arbitrary odd, all values are black or white, correct?
Yeah.
So for the next resulting even, half of the resulting values are grey. Because for each black and white, half of the results are grey. And by linearity of x... I know it's not at all needed. But it
Okay,
sounded
so-
funny to quote that.
Why is it that it is half of each of the blacks?
So you basically just
Because-
told a joke. That's like, you had a chance to prove something.
No, because black goes to white grey, and for even black goes to white grey, and for even white goes to black grey, and so half of them are grey. And actually, it is true by linearity of expectation. In total, half of the resulting values will be grey.
Wow.
Is it by linearity of expectation?
Yeah.
It's an invisible force.
I don't know why linearity of expectation. Oh yeah, no, that's not. No, just don't worry about it. Don't need.
You don't need linearity of expectation, but like, it is linearity of expectation. I'm going.
What do you expect?
No, not this
What
one.
are you
He's very
expecting?
silly.
What is the value that you're
The
expecting?
expected value of the number of greys for each individual black and white is a half. For the odd,
Is
right?
that
And so when you sum it over all the values, the total is half the amount of thing.
I feel like
I don't think that's linear.
You don't need linearity.
it's
of
like
expectation.
abusing like
I don't think
English
that's what
language.
linearity of expectation.
You don't need linearity of expectation at all. It just sounded funny to quote it.
I feel like David's thing made sense to me, and then now you say some crap that doesn't make sense to me. Like you've basically
Okay.
detracted from David's solution. You know?
Should I stop talking?
Yes.
Okay,
Or just start making sense.
So, but I'm never going to make sense.
But so David's thing,
Yeah, so,
basically,
I'm
you're
not
kind of
really-
noticing stuff repeats, right?
Yeah,
And
I
I
think
can
you
get
don't
the
need to.
ideas. It's like
You only need to write out the first 3 lines.
need more.
You don't need to do.
You just
the
need to know how to
last two.
express things.
So is it like this thing repeating,
That's what you need
or
to-
is it more like
It's the
Ian must learn how
this
to express his
thing?
ideas
Is it,
in a way that normal people can understand.
You must learn how to
it's like this, right?
I can learn how to express my desire
Yeah,
to chuck
sort
it
of.
on the balcony.
malnourished child.
I can like with one arm.
Violence is not the answer.
Let's see.
Oh,
Malnourished child.
Alright. So now what happens?
Wow.
But have you got C3?
No,
Is the solution just bash?
maybe it might just be that. I ain't gonna lie. I mean, it's an educated bash, but it still requires computing like 36 things. So,
Oh, can you please explain it to me in a way I can understand, Leo?
Fine.
we have 7 blues right now.
Basically 3 then.
Right.
Basically 3. 3.
For any?
You can use this diagram if you want.
Alright. I don't need the diagram,
Yeah,
but
1, 2,
odd.
10
This is an odd row, right? You can see it's all black and white, right?
Mm-hmm.
Yeah. Therefore, on the next
I think it's
row,
already conclusion.
oh my
half
god!
of them will be grey because each black will go to a white and a grey, and each white will go to a black and a grey.
Uh-huh.
So half of them will be grey, correct?
Yeah.
And on an odd value, any black or white only has one thing it can go to, right? And any grey has 2.
Okay, so on an even value, half are grey. Yeah? Okay, I can believe this. On an odd value,
What happens on the odd?
All are black and white, but for the amount there is, all the blacks, the half that are black and white, they
No,
don't
black
change
and
because
white.
they all can only go to one value. But each grey, the amount of them goes to 2 values. So it's 2 times the amount of greys plus the amount of blacks and whites. So it's 2 times 0.5 plus 0.5, which is 1.5. So it's equivalent to multiplying by 1.5. Do you understand that, sir?
I understood some of it.
Did you understand it, Alex?
It makes sense.
It makes sense to Alex.
Yeah, but like, Alex is kind of like, he could just solve the problem
I have 4 sides.
as... Wait, so you're saying because half of them are grey, right?
Yeah.
In the even spots.
Yeah.
Then in the odd spots, it'll be like, wait, so it's half of them are grey and the other half are like,
Black or white.
you don't care.
It doesn't matter.
Okay.
They act the same.
Okay, and then the grey ones produce 2 things,
Yeah.
and the black and white produce 1 thing.
Yeah. Because half of them are grey, and half of them are black or white,
So there'll be 3 on 2 as many things, which
Yeah.
are black and white.
which is 1 times 1.5.
Yeah.
Okay.
You'll know the respects too.
And the times 2 is because there's no restriction.
Wow. Times 2 is just. Okay, so how do we turn the Liam times 2 times 1.5 thing into that?
Yeah.
That is the
But I still don't like. I still don't feel like what Liam said is like the proof. I don't understand. Like, so I think it does help to know like the odd ones what the possibilities are, right? So you know half of them are grey and the other half are black and white. And then the other ones you know like they're all black and white and there's 1.5 as many. Yeah.
What is this?
Okay, then how do you know they're timesing together?
What do you mean? How do you know that's times?
So you're telling me the total number of things in this tree, right?
Yeah.
So you're kind of telling me
What the hell?
you're telling me this
I thought
and
this
this.
would be like an actual guitar.
Yeah.
But no.
Right.
It just plays a song.
So you're telling me like it's enough just to know the total
Yeah.
on each of these rows, yeah?
Yeah.
And so the total on the nth row is actually the total number of possibilities.
Yeah.
Okay. I think I now get it.
Alright.
Okay, does that make sense?
Yeah.
So, yeah, so now I think, so if you draw this tree, right, the number of leaves at the very end is the answer.
Yeah.
Once you get to the nth row, yeah? And then you're saying on one of these even or odd ones, even ones, half of them are grey. Yeah. And on the odd one, they're all black and white, but
Yeah.
it's equal to 2 times the grey plus the...
Yeah.
Okay. Yeah, so the very top row starts with 2, yeah?
Yes.
And then you just keep timesing by 3, dividing by 2,
Yeah.
timesing by 2, and then timesing by 3 divided by 2, yeah? Until you get to the last row.
Yeah, and then you can prove it's his formula. Like, because 2, 1.5, you can match them up. This is this one times this one 3, 3. So it's either, yeah, if it's odd, it ends on a 3. You can pair each of the previous one up into 3s, right?
Yeah.
And if it's even, there's an extra 2. So it's the 3k minus 1 times 4.
Yeah.
Yeah. It's actually a decent problem.
Okay, now I consider this to be true.
It's actually a decent problem. That'd be a nice AIMO like 6 or 7. Because it hasn't. It looks like the type of thing you'd bash with like counting things. It's actually not a nice solution.
Now, does anyone have questions about this?
You two should ask questions.
Did you do it?
Huh? Yeah, I did it.
Yeah.
I guess I kind of like, I don't know, I just wanted someone to say that this, like, the last row, like, how many leaves there were is actually the answer to the problem. Like, and then it kind of makes sense to time stuff until you get the number of things here.
Yeah.
You know?
Wait, I thought you already knew that last row was the solution.
No, I guess not.
But is it obvious? Or is it trivial?
Yeah, like your goal is to have me not think about it at all, basically. Does that make sense?
Yes.
Like,
You have to say that for any flag from 1 to n. 1 to n minus 1 follows the rules.
Yeah.
No.
Well, it doesn't even need 1 to n minus 1 to follow the rules.
Yeah, so and
Yes,
so
it
you're
does.
you're
If
basically your biggest.
Wait.
If 1 to n minus 1 didn't follow the rules, you can't do the induction thing.
So I guess the biggest thing missing from your thing is like, I don't know. You probably don't need this diagram, but with the diagram, you fail to relate your thing to this diagram. Okay, and that's fundamental to maths, relating stuff.
Yeah.
So you had the opportunity to use this diagram and make me understand it even better, right? By showing what on the diagram is the answer. But instead you ignored it.
Yeah.
Made it more confusing. And yeah. Okay. That was a good idea.
It's actually a decent problem. That wouldn't be a bad like AIMO 6 or 7
Recording stopped.
because it's got like an interesting solution.
Alright, so then we're all on 3 now at least.
3.
3.
3 without bashing how? I don't know.
Can we look at 4? 'Cause
Who's penguin big?
Why are there only 7 working?
Well, I should say hi on all my 5
You should.
1, 2, 5.
Well, the
Multiple of
7
them.
was
See,
beginning
C3 sounds like one of those kind of like very docile questions, but
I don't like C3. I don't know how to do it without bash.
without
C3
bash.
sounds like the type of
I
question
can
where
bash it.
it's routine, but like it's routine.
Is it routine? Because I feel like routine. You
Not
at least
routine,
have you
but
gotten
like-
started on it yet?
I don't know by routine, but routine.
Okay, I'll just do the bash. Whatever.
You've only said hi on one of your accounts.
Yeah, I know, because I have to create the channel to say hi on the other one. So I just create it.
Oh, you're penguin big.
No.
Oh.
Penguin small.
Some random
One,
guy.
two,
Oh. It's like a miracle random guy.
It was just left though.
I'll do the bash.
Has your mum replied yet? Alright, let me know if she does.
Yeah.
Because if you have to go, maybe we'll stop at C3. If you don't, we might go a bit further.
I'll do the bash. There's a probability that another chosen.
Is it multiple of 11?
Your mum's just disappeared. Yeah. This kid no longer has a mum.
Yeah, that was a very
Let's look into the back rooms.
Oh no.
Wait, wait,
I can pick you up and throw you off the balcony with easily.
Exactly, that's me.
You weigh 36 kilos. Wait, how many kilos do you weigh?
35.
35.
You're facts, right?
You could basically fit 3 of you in one Michael.
What?
He weighs 35 kilos.
Michael, let me know that slide.
I don't weigh 105.
You weigh 98. So I said basically.
Basically.
He's like 99.95.
Yeah, that's right. 99.95 kilos right there.
Is that your goal, sir?
No.
What's your goal? 120 kilos?
And now it's like after I lose weight, it sounds funny. It's like I now weigh 80 kilos. 79.95. I once played table tennis with this guy, and he's like, I was like, what's your ATAR? And he's like, 89.95.
Oh, so
I just thought it was funny. I guess because like at that point you don't really need the decimals, right? It's just like just say 90 or like round it to like the nearest.
It's like, what's your ATAR? Oh, 95. Oh, good job. No, it was 95.
0.95.
95.
No.
Nah, the best one, my ATA, 0.95. Literally 0.95.
They don't even tell you the ATAR at that point. They're just like below.
They're just like, yeah.
Yeah.
My ATA, 0.95.
Oh yeah,
Literally 0.95.
That's weird though. I feel like they're doing something sus because not everyone can get a high ATAR, right? But like, it seems like everyone does. So it's
That's
like,
because everyone we talk to goes to a selective school.
yeah.
Do you talk to anyone who goes to like Blacktown Boys or something like that?
Talk to the Cumberland kids.
Oh, such a bomb.
Or you can talk to Slava about that. His school probably have people with low ATARs.
Yeah, I think that we did get someone who got like a 95.95.
Was that the best in your school?
No, not the best, but like I think it was the best like probably.
Yeah, that's kind of sus.
Liam, do you think that'd be the worst for our school?
They're like, the ATARs are predetermined for the school. The range of ATARs, just like who gets more.
ATAR is like literally, effectively your percentile. Like James Roos doing effectively the top 1%, so you should get a 99 ATAR.
What age are you planning to get?
69.
What do you think?
A 0.95.
0.95.
69.95.
Man's getting 0.95. No. How do you do C3? That's
How to do C3?
This is not a routine problem.
It's not routine. It's a cancellation problem.
Oh,
This kid
it's a problem for the computer to do for me.
Oh yeah.
I think your entire problem experience is struggling with the temptation to bash with your computer. Like, I bet you like 90% of your thoughts were just like, do I bash with the computer or do I not bash with the computer?
It's like,
And the other 10% is like,
it's
no,
like-
I don't bash with the
It's
computer.
like me and Junior. I submit like a LaTeX file and it's PDF or whatever, and it's just like a couple hundred pages because I just use.
Oh, that question, was there a clean solution that they presented?
Wait, which one?
You know the one where you use the computer?
The solution is guessing good.
I saw
Eric Longberg.
Yeah, we know. He's probably your favorite person.
Yeah.
You aspire to be like him.
How did you know?
How do you do this?
That's
Oh, yeah,
it?
Liam.
Oh, okay.
What then?
What? No, you got second.
But I said something second.
Oh.
It's just a normal, it's not like this order.
Didn't he have like? He looks like your average what could be, and you also be those students in 5 years after high school.
Tell us the Kit Kat. Yo.
哦，掉了！哇，我居然能接到，我都没看清楚，我就选到。哎，干！
I feel like the most torturous job for Michael would be to get him to teach a bunch of preschoolers.
Or a bunch of
Because they do not have the intelligence to do anything he
How
wants
does
to
Michael
do.
have one
So he'll be
when
forced
only
to do the
have five
monotonous,
accounts?
torturous stuff. He has nothing he wants to do. There's no reason
I feel like a bunch
I
of
mean, I wasn't that bad at school.
Yeah. But like, will most teach a bunch of average, special needs preschoolers?
What special needs?
Special needs.
Like the
Does that
preschoolers with
exist?
learning disabilities.
Michael, how do you have one viewer if I'm
He's not.
One watching now, damn.
Who is it?
That's all.
I'm on all the time.
Mine says set to watch.
Actually, for some reason, I just thought of some group theory stuff.
Oh, group theory. Why are you thinking of group theory? How does this relate to the seed group?
Like,
Oh wait, are you thinking of like the digits as permutation?
yeah,
What? Wait. that's-
orbit stabilizer.
Whoa, wait. Damn. What?
Wait, does it work or not?
I
So,
don't know. Let me.
Michael,
How does
explain.
the permutation affect it?
so in group theory, it's like, basically, you have, so the group is like, for example, permutation.
Yeah.
Like, and the set is S. Yeah. So like a group acts on the set S by permuting the digits.
Yeah.
Right. And and so what happens is like when you act on the set gets divided into these things called orbits. Yeah.
Yeah.
So like, so maybe in this particular set, there's only one orbit because you can get from anything in S to anything else in S.
Right. It's like, can you find like a? What's it?
But I was thinking like if you can restrict to like the multiples of 11, right?
Yeah.
Let's see.
You commute a multiple of 11 with another multiple of 11, you get a multiple of 11. Wait.
Yeah, it's like how can you like which things preserve the multiples of 11 when you put. But now it sounds like not as natural, but it sounded better at the start.
Theory for C3 from Crestwell. That's actually.
Yeah, but the point is, if there's a lot of symmetry, the group theory thing counts a lot of combi things pretty well. Maybe there's something people can do is find a multiple of 11. Yeah. Find me a multiple of 11.
Okay, wait, okay,
6, 9, 5, 8, 7, 4, 1.
whoa, he's got a multiple of 11. I'm gonna write another multiple of 11.
I lost the calculation.
Wait, I've kind of got a different way of looking at it.
Whoa, I got 4, 1, 6, 2, 7, 3, 8, 5, 9.
Wait, instead of looking at like the individual, look at all the distinct sets, ways you can split it into two sets of 5, the two subsets with 1 to 5 and 1 to 4 methods, such that the number of ways to split into those two subsets, such that when you subtract one subset from the other, a number that's multiple
Well,
of that.
because because 1 plus 2 is 45. That's 1 mod 11. It means that both of the subsets have to add to 6. But
First step adds to 28, second step adds to 17.
Oh, what's this?
600.
Yeah, like you separate, get 11 numbers, right? And then you take all the digits on the odd places, right?
Wait, 11 numbers?
Yeah.
Just like 1, 2 to 11.
Not 11 numbers, 9 numbers, sorry.
Okay.
Once you take all
Like that, yeah.
Yeah, and then like the 1, 3, 5, 7, 9, the digits on the odd places, they should add to 28.
Okay.
And then the digits on the even places should add to 17.
Like that.
Okay. Oh, which is
Because
0 mod 11.
yeah, because like
I can't go that way.
for the set of numbers on the odd digits A, and the other set
I can't do that, man. I don't have
is
to.
like A minus B is either 0, 11, or 12, or 22.
Wait, say that again.
So
Ah, okay, I can't do it.
so for the set the sum of the digits on the odd place is A. For
Oh,
example,
okay, yeah. There you go.
and then you have the other digits which sum to B.
Okay, yeah.
Right, so A minus B is either 0, 11, or 22. Because,
Fine, you can sit on this.
Equals 0, 11, or 22.
yeah. And then A plus B is always equal to 45. So you just solve the equations. And then 0 and 22 don't work, because you end up with decimals.
Oh.
So, yeah.
Push-ups.
Wait, why is it 0, 11, or 22? What can't it be like negative or...
Okay, you can
What
get
can't
out
it be
now, Slav.
30?
Oh, wait, might be because yeah, it could be negative as well. I forgot about that one.
But I think
It could be like
only
negative 11,
one way to.
but it can't be larger than 22.
Right.
Oh.
There's only one way to split
And why is that?
two distinct
Because
subsets.
if you make the numbers on the
Because they need to be
odds,
equal mod
like
11,
the
right?
biggest one, for example, if you
Subsets.
make this one 5, 6, 7,
And because
8,
all the
9,
values aren't
it's a
equal
1,
mod 11,
2,
there's no
3,
way to
4.
swap two
Yeah.
The
values.
difference is only 25.
Oh.
So,
Yeah, but like it's
Okay, so maybe like go
It's still
minus
just
11, minus
complicated.
22.
yeah.
There's a few. But like, I think just bash this. Like,
Wait, I think David has an approach that might
what
work.
is it?
So he basically considers the even digits, right?
Yeah.
And calls them B, the sum B, yeah?
Yeah.
And the odd digits sum to A, yeah? And then he basically got that A plus B has to be 45, right?
yeah.
And then A minus B has to be, I think he said 0 minus, plus or minus 11 or plus or minus 20. But at least it's not 33, yeah?
It's not
It can't be 33 or higher. But we don't know if it can be minus 11 or minus 22.
It has the knowledge.
And that way you can solve for A and B.
Whoa.
And it's if and only if, right?
And then you get. Wait.
So he has reduced the number of cases that we need to check.
I've got. Wait. I have an approach as well. It's kind of different. Do you know how you have the odd and even ones, right?
Yeah.
You can split them into a subset. So you have 9 values. A subset of 5 values and a subset of
Yeah. Basically, what I figure out is like A and B have to be 6 mod 11.
And the
6
number
mod
of
11.
ways you can split
Really?
into those
So
subsets.
45, that's 1 mod 11.
Oh.
And then so basically trying to get like A equals B and then A plus B. So it's like 2A equals 1, A equals 6.
Right. Does anyone have an example of one number that is 0 mod 11?
One number.
Yeah, just one.
One number of what?
That's,
Yeah, it was this number. 1, 2, 3, 4, 5, 6, 7, 8, 9.
is that number itself to simplify 11?
2
Yeah.
plus 4
I think
plus
it's-
6 plus 8.
Right.
What? Wait, 2 plus 4 plus 6 plus 8 is 20. That is
Wait, what was the number that was 28 and 17?
I haven't figured that out yet.
Oh.
I just need one subset.
Wait, how did we get 28 and 17 then?
You solve the two. Wait, like, you solve for 11. No, you solve for 0, 11, and 12, or 22. 0 and 22.
Oh, you're trying to add it to 45.
Yeah.
Oh. Okay. Alright, yeah, I think this approach will work.
This approach will work.
Recording in progress.
Okay, so for C3, the approach David came up with was sum up all the So A was the sum of all the even or odd ones. Let's say odd. Sum of the odd digits. Okay. And B is the sum of the even digits. Slava, are you watching? That's delayed, isn't it? Oh, you can. So A and B are the sum of the. So remember, divisible by 11 is just A minus B has to be a multiple of 11. Yeah. And A plus B we know is 45.
Well, what
Oh, we
is
know-
minus 11?
Yeah.
Oh wait, no. Can it be minus?
I put it here. Like we know it can't be 33 or higher.
Oh wait, yeah.
And so then I think Alex said if A equals B mod 11, it has to equal 6. Is that what you're saying? So A equals B equals 6 mod 11. No? So
Oh yeah, that's that.
you're trying to think of 4 numbers which add up to 6. Which add up to 6 mod 11.
Yeah. And I was trying to count how many, but then I failed.
Yeah, if 4 numbers add up to 6 mod 11, the other 4 have to add up to 6 mod 11 as well, right?
Yeah, so B could be like 2 plus 4 plus 5 plus 6.
2 plus 4 plus 5 plus 6.
Yeah.
Wait, is that 6 mod 11? Oh, yes.
Ooh, wait. But I think that
6 and
So this adds up to 6 plus 11, right? Like the biggest 4 numbers, 9, 8, 7, 6. Can be 6 plus 22, or 6 plus... Yeah, so it could either add up to... So the smallest 4 numbers already are over 6. So it can either be 6 plus 11 or 6 plus 22, yeah? For A. For B.
okay.
Yeah.
But you can just, because we have the 2, 4, 5, 6, and 1, 3, 7, 8, 9, right? Solve the problem for that. Because you can just case bash the ways to swap it so it still remains 6 mod 11. And then that gives you, once you know that's all the values, that gives you all the possible sets for the even and odd. Work it out.
Alright, so 6 plus 22 should be easy. 28. Can you even get 28? That should be easy, right? If it's possible. So 9, 8, 17. So this is 30, right? You just need to reduce it by 2.
Small amount.
So like 9, 8, 7, 4. Yeah.
9, 8, 6, 5.
Yeah, like you can reduce 2 of the numbers by 1 or 1 of the numbers by 2.
And those are the only 2 cases.
What?
Those are the only 2 cases.
Are these the only cases? Like, do you need the 9?
They might be the only cases.
If you don't have the 9,
Yeah. Can't really decrease the... You have to decrease the 6 at least 1 to decrease any.
yeah,
But then if
you have to have a 9. You have to have 9 and 8.
You can only decrease 7, so these are the only 2 cases.
Yeah. You need the other 2 numbers added to 11.
What about 6 plus 11 equals 17? Bro, this question is a scam. Like the AMC again.
Hmm. 6 plus 11.
6. I'm going to write all cases.
Yeah, so once you get the number of ways to do 6 plus 11, that's the problem solved, right? So you already have 2, 4, 5, 6. That's already kind of like the smallest. So 1, 2, 3, 4 adds up to 10. Hmm. Two, 3, 4, 5, 14.
4, 9, 5, 13
Yeah, so if there's no 1, there has to be a 2. What? 4 possibilities
Yeah.
for B,
Yeah.
for 6 plus 11.
Yeah.
That up to 17, yeah?
Yeah, it's like 2, 4, 5, 6, 1, 4, 5, 1, 4, 5, 7, 1, 3, 6, 7,
1, 3, 6, 7.
and 1, 2, 6, 8.
1, 2, 6, 8.
Well, about 1, 3, 5, 8. And 1, 3, 4, 9. 1, 3, 5, 9. 1, 3, 6, 8.
I feel like there's a lot with 1s, and the ones without 1s have to have a 2.
4 plus 5, that's 10, so 7. Okay, now I move on to 2. 2 can 2, 3.
The 3 can switch out.
2, 3, 5. I need that add up to 17 minus 12. 4, 8, 5, 7, 2, 4, 5, 6. Okay, that's all the cases, right? If I try to do 3, 4, that's just too many. Okay. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 different possible choices.
Add up to 12.
That is the bathroom. I can see that.
5 and 7.
I got 9 different ones.
5
This
and
is case
7.
bashing. I am very depressed. I am this problem is
4 and 8.
not a nice problem.
5 and 7.
Holy shit, he's using the same notation I'm using.
Oh, but it's not fitting in the box. Oh wait, 3 is repeated. Maybe the box cannot be fit anymore.
Yeah, I basically just like the left 2 numbers, I want them to be like the smallest 2. To make sure like I don't repeat anything. And then
Yeah, I think that there's more with 1s.
and I just bash. There's like one. Okay, I got 1, 2, 5, 9, 1, 2, 6, 8, 1, 3, 4, 9, 1, 3, 5, 8, 1, 3, 6, 7, 1, 4, 5, 7.
The 1, 3, 5, 8 was missed. 1, 3, 5, 8.
And also 1, 3, 4, 9.
1, 3, 4, 9.
This really sucks. Okay, so I get 11 possibilities in total, adding the 2 from the other case. And I just have to divide that out of, like, 9 choose 4.
Yeah.
Which is, what is 9 choose 4?
The thing is, like, once we got these numbers, what to do is kind of easy, but like, that step is like
Yeah.
what people do in school maths and they'll like never even do it. It's kind of weird.
9 times 7 times 2 times 9 times 7 times 2.
Oh yeah.
Alright, so we got a total of what,
Maybe I just leave it like that.
we got 8 cases for 6 plus 11 and 2 cases for 6 plus 92. Is that right?
8? How
Did we get 8? Wait, how many did we get?
You can just count up the number of
1,
cases.
2,
and then
3,
it's
4.
Yeah,
just-
but you haven't. That's the thing. You haven't.
Yeah, but you guys are counting it.
Oh yeah, there's also
I'm not
1, 2, 5, 9.
Sit down.
Oh, 1, 2, 5, 9.
1, 2, 5, 9.
Yeah, I think we should be systematic about this. So you could be like 1, 2, and then it's like
1,
things
2
that add up to
stuff,
13.
1, 3 stuff, 1, 4
1,
stuff.
3. Yeah.
Yeah, that's what I did. And I did 2, 3, and then 2, 4. And then I-
Wait, is it 1, 4, 9, 3?
1,
Wait.
4, 9, 3. That's, we already did 1, 3, 4, 9.
Oh yeah, you ordered it wrong. Yeah, okay, so that's how it's being stupid. Okay, so yeah, stuff bigger than the first two.
Yeah.
So if it's 1, 2, it has to add up to 13, right? 7, 14. And to add up to 14, you need like at least 5 and 9. And then you have 6 and 8 and 7 and 7, but you can't have 7 and 7. If you have 1 and 3, you yeah, if you have 1 and 3, you need to add up to 13, and the smallest combo is 4 and 9, and it's 5 and 8, 6 and 7, and that's it, yeah? And if you have 1 and 4 as your smallest, you need to add up to 12, and then 5 and 3 and 9 is, the 3 is too small, so you need to start with 5. And so there's only 1, 4, and then 2, then it has to start with a 2, and then it could be 2, 3, or 2, 4.
Yeah.
Yeah, because if it doesn't have a 3, then that's the smallest it can be, right? And if it does have a 3, then that's 2 combos. Yeah, so that's everything. So it's 11 combos. Sus. 11 is divisible by 11. Sus.
What's going on here? Bro, this is literally school math problem in the C3. Who put this here?
Can you get rid of Slava and Alan? They seem to have decided their entire purpose here is to try and annoy me. They kept throwing a pencil at me.
No, I think you also don't realize it's Alan who's trying to annoy you. Slava is not.
Slava's
Slava's
trying
not
to be
focused
friends with
enough
Alan.
to annoy you in a focused way. You need to focus on something.
Slava's just friends with Alan, so he's doing what Alan wants to do, which is annoy me.
Okay, and then to get the answer, you need to times it by the permutations of this, and then by the permutations of the other one. Yeah? And then add them all together. Yeah. So it should be 11 times 4 factorial times 5 factorial.
Yeah.
Divided by 9 factorial.
11 factorial.
Huh.
Wait, no. 11, oh, wait, no. 11 times 4 factorial.
Huh.
What about it?
Wait, so the answer seems to be what? The answer is like 11 over 9 choose 4 or something?
That's what I did.
Is that the answer?
I don't know, maybe. Probably.
But why 9 choose
Probably.
Yeah, like why is the probability 11 over 9 choose 4?
It seems to work. I think it just works. Because there should... Okay. Well, if we want to do that, we're claiming that dividing the number of choices of evens by the total number of choices is equivalent to dividing the number of multiples of 11 by the total number of s. So that is the claim.
Yeah.
So we need to check that there's the same number of You check those the same one.
Yeah, I guess we did
Well,
figure
the
out like
thing
if we
is-
just choose 4
But the
things,
thing is
11 of those.
For each choice, there's definitely going. For each choice of the events, there's gonna be exactly 4 factorial times 5 factorial.
Yeah,
That fit that choice.
yeah. Like for each choice of the evens, there's gonna be like 11 that work. We just kind of showed.
Yeah.
But why
Kind
would
of
we do
just cancel.
Yeah.
Basically, like the top and the bottom.
Alright, any questions about that? Alright, lunchtime. Okay, we might leave C4.
Recording stopped.
I've realised something. The AMT lacks the brain power.
Oh, yeah.
I said some good questions, like C1 and C2 were decent questions, but C3.
AMT hears Liam in the video, it's like copyright.
Copyright. I think it's kind of annoying because they told me to take the video down, right? I did it literally instantly, and then I still get sent a copyright strike.
Maybe
Yeah, I don't think that makes much sense. Maybe.
Really?
Yeah,
Why?
because I would explain it. Because.
But I just searched and then I removed all the ones that had.
Maybe you missed something.
What did you search?
2023 AMC. Alright, so make sure this table is somewhat clear. And then food will be placed on. Oh, I haven't ended the stream. So while we're transitioning to lunch, I think I want to do some. I want to finish up that continued fraction thing. So while you guys eat lunch or something.
Yeah.
Because that's kind of like a one-off. I guess you kind of also missed. We proved that like, the continued fraction. Like if it was a solution to Pell's equation plus or minus 1, it had to be at the place for which it has to be at a multiple of a period.
This was successful.
Alright, lunch.
Yeah. Has Alan decided his purpose in life is to annoy me?
I don't think it was. I think it became that after you kind of became
After I became what?
annoyed. I don't know.
To be annoyed, someone must have had to annoy you. But he didn't annoy me in the first place.
The other thing is, like, in these interactions, you probably don't genuinely dislike Alan, but
No.
I could understand if he genuinely disliked you.
Why?
Because.
That was very clearly sarcasm. Why could you understand if Alan...
Just like Stefan. The ex-student known as Stefan.
But I haven't done any of the stuff I did to Stefan to Alan. I've never called
Isn't
him
that making a...
He has learned.
Like, I haven't done anything to make Alan genuinely dislike me. He's just decided to annoy me.
I don't think so.
What have I done to make him dislike me, sir?
I think you're thinking about it the wrong way.
So my existence makes people dislike me.
Not exactly.
Okay, so remember when we did continued fractions? So, like, when you write things like...
Isn't that in the Trivia
No.
Huh?
Isn't that the Theorem in the Trivia math book?
Yeah, but this is going to be like the senior version, or the intermediate version. Alright, I think I need to help with lunch. So basically, if you do a continued fraction... like say you do root 2 and it equals like 1 plus 1 over 2 plus 1 over 2 plus 1 over 2, right? Dot dot dot, yeah. And the question is like if you stop it like here without the dot dot dot, what's that fraction equal to? You know, like this is P4 over Q4. Yeah. Okay. So we wanna find a recurrence. It's kinda like this. That explains how to get the numerator and denominator pretty quickly without doing the whole fraction. Okay? But the catch that makes this intermediate or senior is that none of these things are integers, they could be complex numbers. Okay? So these could be complex numbers. Alright? So we just have a random kind of because there are moments where it's more convenient to insert like a because if you say they have to be integers, right? Then like there's some tricks where like you want to kind of insert the tail as one of the entries in the continued fraction. Doesn't make sense anymore, right?
Does it work? Are you sure you can do that?
Yeah. So now I basically want to show what happens for possibly. So the good thing is that the continued fraction is now finite. Yeah. So root 2 goes on forever, but if you allow them not to be integers, you can kind of put the tail in one thing. So like this whole thing here could just be like 1 over alpha. Yeah. Okay. So then it's finite, but alpha is no longer an integer. You know what I mean? Yeah. And so we want to prove something like this. So here we write root 2 as 1, 2, 2, and then you can either have like an alpha to represent the tail, or you can write 1, 2 repeater.
It lets you move when.
那个是用的橄榄油，它也可以吃啊。
Hello, sir. So I don't think you're allergic to this, right? Isn't you allergic to literally everything in existence?
Who, me?
What is he allergic to?
What are you allergic to? No, you're just taking the whole thing. I've already just grabbed the whole thing.
I'm very sorry.
I'm just saying that.
Damn. It's time to eat the flower circle.
Yeah,
Damn.
Oh yeah, did you know Evan Chen once failed a driving test?
Driving test? Yeah.
How do you know this, Liam?
Oh, he posted it. So basically,
Driving test should be pretty easy, I think.
supposedly he was thinking about an inequality while doing it.
Nah, bro. This inequality was his speed exceeding the speed limit.
Oh yeah, Evan Chen supposedly sleeps at 10 p.m.
Damn. Then how come he was able to reply so quickly? It's like because he replied to an email before 10 p.m. and he can't reply to Liam's next email.
No, because there's a thing he posts.
That's the level of freedom.
That's like a day in the life of Evan Chen.
So now you know his entire daily schedule?
Yeah, time to storage. Wait, do you guys want cheese? Cheese. But only in slice form, I think.
Broccoli wrote the whole schedule down in his notebook.
Why is Liam such an avid Evan Chen fan? Oh no.
Y'all must eat garlic bread. Otherwise, vampire.
Right.
So Liam, if Evan Chen came to Australia and lived here permanently, would you quit here to go to him?
He doesn't run a children's cult, sir. He doesn't run a cult.
But if he did,
I know, I have that. He's like, no.
this is
Probably not. I would probably not.
I mean, Liam could probably afford to go
He
to
could
work.
probably go to boat because he's that rich.
now that he's been confronted about it.
Looks like Liam's not a vampire.
Right. Currently, we've got pizza scheduled for Thursday.
Yeah.
But if David wants to stay longer on Friday, we can reschedule it to Friday.
We only have more people on Thursday.
Huh?
We have more people on Thursday.
No. It's the same. It all depends if David stays for lunch, though. Because
I need to
It's
know
a big
when do I
pizza.
not eat lunch dinner.
and I feel like David might be more productive than a girl eating pizza. Because Thursday is Jesse, Friday will be David. Typically, like, girls can't eat half a slice of that pizza.
Yeah.
But at least decide because I need to know when to not eat
There's
dinner.
no way,
And breakfast.
realistically, we're not going to finish this pizza. Alan is sub half a slice, probably.
Yeah. No, wait, let me know if you want to stay. If you stay longer on Friday, let me know.
Okay.
But then we'll have pizza on Friday and shit. And I'm gonna tell Ryan because I'll keep forgetting to tell Ryan. Ryan's coming just to eat the pizza. He's not coming for class, so he'll come at lunchtime, eat pizza, and leave.
Are we going to the restaurant?
I don't know yet. I think my thing is like if they do delivery, will it be a worse experience with delivery? Because they'll probably put it into different boxes and stuff. I don't know.
Yeah.
We got pretty close.
But then the question is, how do we get that? Like, I don't feel like we won't waste as much time getting there because even though like because
Where is it?
It's like if you go down, it's
Liam, my contribution.
I feel like it's right next to where you turn left for your place, like the Castle Hill Road thing. That intersection.
Thank you. Very kind.
Yeah, so like getting there, I feel like because it's cooking time.
Oh,
Like, we won't waste any extra time than normal. But coming back will be a bit of waste of time. Unless we just start ferrying the people who like get full out of the like busting dirty plates.
If you don't finish, you should start inviting random people on
I
the
feel like we're
street.
not going to... Realistically, you need to get more people to come. Because, like, Slava and Alan do not strike me as very much big eaters.
Yeah, especially when I
we
ate
just
that
need-
15 meat pies and I was so hungry.
Must that not equal to 0 slices?
Honestly,
I used to be able to eat a lot, but I feel
I
like these
can eat,
days.
like, if it's yummy, I can eat, like,
It's very clear that you used to be able to eat a lot, sir.
oh,
That wasn't really nice. Liam.
Michael, are you gonna let that slide?
Yeah,
Oh,
just pick a battle, Slava.
You also can't exactly disagree with that.
Michael only picking battles he can win.
who's the Roblox? It's Michael.
Oh yeah, Blox Fruits competition.
Michael picking the blocks fruits battles.
Hasn't Michael been grinding blocks fruits?
So I just realized I literally can log into my friend's map to block music.
Yo.
None.
What level is your friend on blocks fruits?
Math. Like, literally, I just know one of my friends is math.
What's the max level?
I don't know, but I will math.
It's 2450. It's a sign that lots of time has been wasted.
Yep.
What is blocks fruits?
Roblox One Piece.
What's that?
So he didn't explain anything. Like this anime
No, like you
manga
just
thing called One Piece, right?
Yeah.
And then it got turned into like. I don't even know how this game is really related to that. I guess is it the name of the things are related?
The
No,
fruits.
the fruits.
Oh,
And like the map.
bro, this guy just like he just says what it is in his mind.
he says how he understood it.
Yeah.
Literally, like exactly.
The phrase "think before you speak" does not apply to Liam.
He's gotta learn how to like formulate his thoughts into words.
I can see how that could be irritating.
It's like every time he opens his mouth, it's just like word garbage, you know.
Yeah, okay. As
whatever's-
cool as it is for us to all dig into Liam, if you're younger than Liam, I think you gotta kind of lay back a bit, okay? Because
Just four months younger.
like, if you're
I think you
inferior to
gotta-
Liam,
Wait,
you're gonna watch what you say.
Just-
But if you're superior, keep carry on.
Michael does.
As perceived by Liam.
So Alex and Michael can carry on.
Okay,
Well, that is the true statement.
but that doesn't say none of them can carry on. It just says we can carry on. See, if and only if.
Carry on.
Alana and Slava are the only ones of them who can carry on, who want to carry on, and they're the least worthy of carrying on.
Yeah, I guess it's also worse that they look a bit younger than they are as well.
Yeah,
I think Slava might actually be older than you.
No, except 4 months older.
Well, there you go. Respect
I
your
don't even
elders.
think Alex is like carrying on. He's just trying to give helpful advice. I feel like
Who's carrying on?
Alex is just trying to give helpful advice.
Oh, Alex doesn't carry on.
Yeah, Alex trying to. He's just genuinely giving helpful advice.
Yeah, okay, so
Recording in progress.
Yeah, where did the period thing come from?
the tricky thing about this is like, how do we even state this claim? Okay, what am I
What is
even
the
claiming?
What is the claim?
Like,
Clearly,
wanna-
I didn't understand the claim when I was trying to finish off answer. So,
so wait, which? Okay, so there's lots
like,
of
where do you end it to get the solution to the problem?
where do you end it? Oh, okay, just from continued fractions.
Yeah.
Oh, okay. So the overall claim for that, which is not what we're doing completely right now, but this will be a piece of that.
What do you do?
So if you have root n, right? The continued fraction always looks like this. So you take the floor of root n as a1, okay? And then there'll be some random stuff, a2, a3. But like, it'll go up and then it'll go back down, like a palindrome. Back to down to a2, okay? And then it'll end with a 2a1, okay? And this part repeats, okay? Okay, and say that's like the first, that's like the period, like the smallest repeat, right? Then this number here, like, so the length of that is the period, yeah? Okay. So the claim is, if you take the continued fraction and you cut it off at a multiple of the period, okay? So, in this case, so like, for example, if you have root 3, okay? Root 3 equals 1, 1, 3, and then, wait, root 3 is 1, 1, 2, right? And then that repeats. It's like this, yeah? So it's saying, like, if you cut it off at any multiple of, so the period is length 2, right? If you cut it off at any even number of places, so like it could be like 1, 1, 2, 1, right? Then then that'll give you a solution to Pell's equation plus or minus 1. And it'll give you all the solutions to Pell's equations plus or minus 1. Oh, but if it's even, it's going to always give you plus 1. Okay? There are no solutions to Pell's equations minus 1. You know what I mean when I say Pell's equations? So Pell's equation is like, for this root 3, it's x squared minus 3y squared equals 1.
Wait, what is x and y?
They're meant to be so for example, if you take 1, 1, 2, 1, right?
Yeah.
That's the continued fraction. So it goes 1 plus 1 on 1 plus 1 on 2 plus 1 on 1. Yeah?
X and Y are integers.
And so this is 3, yeah? This is 4/3, and there's 3 on 4, and 7 on 4, yeah?
Yeah.
So this is equal to 7 on 4. Yeah?
Yeah.
And you'll also notice that 7 squared minus 3 times 4 squared is 1. Yeah?
Yeah.
Yeah, and the claim is every even finite fraction that you get from cutting off the tail is a solution to that equation. So this is kind of a cool way to solve the equation. That makes sense?
Yeah, yes. X and y in the simplest form.
Yeah, like if they had a common factor, they would have to divide 1.
Yeah.
So they wouldn't have any common factors. And then it also happens that this never has common factors when you do this. Yeah. So if it was equal to a square instead of 1, you just find it equal to 1 and times it by a square. Or divide out by the square. Alright. But notice to get 7 on 4, we did like 3, 4/3, 7 on 4, yeah? But there's like a faster way to get these. The way you get these is instead of, so because we know the continued fraction looks like 1, 1, 2, 1, 2, yeah? And let's say we know that, wait. Okay, and we know that, like, so say we know that this, like, we know the first few values, yeah? So the first value is like 1 over 1, yeah? Then it's like, 1 plus 1 over 1, which is 2 over 1, yeah? And the next one is, as we said, was, wait, what's the next one? So 1 on 1 plus 1 on 1 plus 1 on 2, right? So it's 5/3, yeah?
Yeah.
And then we said this one was 7 on 4, okay? How we get 5/3, another way to get 5/3 is you can just look at the numerators, okay? So 5/3, wait, what the hell? Yeah, so 5/3 is like here, right? Yeah?
Yeah.
So what you can do is you can do 5 equals 2. It only matters for this entry. These you can ignore the other ones. So it's 5 equals 2 times 2 plus 1. Yeah?
Yeah. Yeah.
Okay. And then if you go to 7, right, it's here, yeah? 7 equals 1 times 5 plus 2. Yeah? So the formula is it's whatever one you're up to times the previous one, and then plus the one before that.
Okay.
Yeah. So that's why you have it. That's why it looks like That's why this looks like this. Yeah.
Yeah.
And it's the same for the denominator. Like what was it again? It was like 1 on 1, 2 on 1, 5 on 3, 7 on 4. Yeah. See, 3 equals 2 times 1 plus 1. 4 equals 3 plus 1. Okay, but we want to prove this recurrence even if this is not an integer right now, okay?
Does that make sense?
I don't know. So what am I trying to say here? Because there's a lot of parts where like it's kind of used in the proof of even when it is integer.
I feel like it just works with the proof. But like, only if you do P of... The thing is like, now that it's not integers, you don't have like P over Q anymore.
No.
So you have the number, but it's like not reduced form because it's not already done.
Yeah, so let's have a look. So if we have a continued fraction, and we just have like a1 plus 1 on a2, let's just have that, yeah? But this is just like a1, a2, yeah? And we have no assumptions on a1 and a2, except that they're, yeah, so they could be like complex numbers. Like that'll still be, you know, like, what will that be? That'll be like a1 plus, so a1, a2
Oh yeah, wait,
plus 1 on a2, yeah?
didn't the proof for the integers depend on the somewhat? Like, what we did was basically like, we replaced the last
yeah.
A with something that wasn't in it.
Yeah.
So like, I guess we already proved it.
Yeah, so maybe we just need to check that we proved it then. Okay, so okay, and then obviously a1 is just equal to a1 on 1, right? But actually it's not that obvious, is it? It's equal to a1 on 1. Like
Yeah, because
you don't like what
anymore, like, I guess you could
like yeah, like what, because if it was a fraction, then you know what integer to take as the numerator, which one to take as the denominator, right? But if it's a complex number, like you could literally make like 2 the numerator and 2 on a1 is, you know, like a1 on 2 is a denominator, you know? You know what I mean?
like 2, you just multiply 2. Yeah, I don't know. It's like it's just one of the representation.
Yeah, I feel like then the claim has to be something like this. So it's like,
Then you have to do like,
it's like the claim is like this: a1
Pn on Qn.
an equals pn on qn, right?
And then you define Pn on Qn. Yeah. It works.
How did you just chug the entire brain?
What the? How did you do that?
How did you just chug the entire brain? Easy process.
Why? They may not have been a bad decision.
아보카도 교환 오늘도 복싱. Hey.
Yeah, it's kind of a weird kind of claim. It's kind of like it's true for all a and n. So how does this proof work? Okay, so I think it's probably good to define the sequences Pn and Qn separately, yeah?
It's kind of weird. Unclear.
Yeah, so we're kind of saying, like, no matter what the continued fraction is, as long as it's finite, right? it'll be given to you by these Pn and Qn's, which are defined from those things like that. Yeah. So here in the proposition, I guess we define the Pn and the Qn's. Yeah.
And then prove that Pn and Qn.
And then we get this for all. Yeah, so I think it's key that we induct on the length of the expressions, which is kind of like, it sounds easy, but like we're kind of saying like what's the induction hypothesis? Yeah, like we're kind of saying that whenever the length is n, yeah, then it'll work no matter what the a's are.
What do we assume?
Yeah.
Also, how do you eliminate the...
Huh? Yeah, I think Alex already kind of knows what's going on. I'll just show people what we're doing. So, okay, so if it's k equals 1, right? So what does k equals 1 mean? It means that anytime you have a continued fraction where it's just a1, right? And actually a1 just equals a1. And then this will equal to p1 over q1. Yeah? But p1, we define p1 to be a1, yeah, and q1 to be 1, right? So then it's true. Okay. I think we probably need at least 2 base cases, right?
Yeah.
Okay, so when k equals 2, right, then we're trying to show that no matter what a1 and a2 are, yeah, then that's equal to p2 over q2, yeah. Okay, but we've actually just defined p2 and q2, so there's nothing really to check. We've defined p2 to be a1, a2 plus 1, and q2 to be a2, right? And we already checked that. Okay, so for some reason we checked 3 as well.
So I take the Pn on Qn. What's the claim? So the claim is Pn on Qn equals alpha n Pn minus 1 plus Pn minus 2 on, wait, no, it's an Qn minus 1.
Okay, so maybe we don't really need 3, but let's just do it as an example, yeah? So I think we did this in junior, yeah? You read this. So now P3 is equal to that, right? And that is literally P2. So P2 is that times A3.
Now we sub the
plus P1, right?
So we want to sub in Pn plus 1 and Qn plus 1.
But this time we're not concluding that it's what P3 is, you know what I'm saying?
An.
See, this should just say equals P.
We're checking is true for P3 on Q3.
Yeah.
And then we can do induction.
So it's not that P3 on Q3 equals that. It's that the brackets A1, A2, A3 equals P2.
What do I want to set An to? I want to set it to 1 plus. Wait. No,
yeah. So the proof in the junior one is actually like I mentioned that there was an issue, right? I don't know if people noticed it. So here it's A1, A2, A3 equals that.
Very strange.
Yeah, so this is kind of in the wrong way too.
Then everything just works. Over the same thing on the bottom. This equals, I factor out the an plus 1. It's 1 times an pn minus 1 plus a plus pn minus 2 plus pn minus 1 over the same thing, which equals an plus 1 times pn plus pn minus 1. Yo, I did it. Over the same thing. Yay.
Yeah, so what should this statement be? Any sequence of complex numbers, Pi and Qi be defined by that. Yeah. Okay, so the base case is done. Now induction, yeah? So what are we assuming here? So the induction is not assuming the recurrence, okay? Because that's how we define it now, yeah? It's assuming that this works for all things of length. Works up to k or n, yeah? So we're assuming this is true for all continued fractions of length k or n greater than or equal to 3 or 2. We prove that it is true for all continued fractions of length n plus 1, right?
It does not depend, in fact, on the not complex.
Yeah. So
Works for any field.
yeah, so then we're looking at so a1 dots a n plus 1, right? And we want to show that that equals to the pk n plus 1 on q n plus 1, yeah? But this equals a1 dots and then the last thing you can write it as a n plus 1 on n plus 1, right? So you can write that as that, yeah? Okay. And now it's good because it's a complex number now, right? So doing, like, if you had this only for integers, then this wouldn't work, yeah? And so it's supposed to work for all things of length n, right?
Yeah.
Okay. So, and the point is all the p's before the nth one are the same as the p's that you want to show it here as well. Yeah. Okay. So this equals the Pn because up to I equals n is the same as required, right? Wait, what's the very last thing? It's n. N minus 1, right? Oh, the nth. Is our desired PIN plus 1, right? Yeah. That makes sense?
Yeah.
So like if you look at this tricky expression, right?
Yeah.
You know how to get that? You know how to get that?
Oh.
So it's basically like if you do like 4, right? If you have like A1 plus 1 on A2 plus 1 on A3 plus 1 on A4, yeah? You can write that as A1, A2, A3, A4, yeah?
Yeah.
Yeah. Or you can combine these two into one and write it as A1, A2, and then it's A3 plus 1 on A4.
Yeah.
Yeah? That's what's being done here.
Yeah.
And because the induction's on the length, this is a shorter length, right?
Oh yeah, that makes sense.
So all of these P's are the same, right? P1, P2. But here the Pn is actually the Pn plus 1 of the longer one, right? So the last thing here, the Pn of this, is the Pn you want to show it's equal to. Yeah?
Yeah.
That makes sense? Because all of these are the same, right? And this one's different. But the nth one of this one is the n plus first of the other one.
Yeah.
Okay.
Oh yeah, so confiscated my phone from myself and gave it to you.
Oh, very good. This is brilliant.
Picking Oh my god!
So I should ask if Charlotte's coming on Monday. No, alright. So okay, so then we get that. Then we get basically this kind of expression here, right? So we put this am plus 1 on am plus 1. Because you know that all the p's for this satisfy all the relations that's defined, right?
Yeah.
No, so I'll write it properly. Let's see. So it's what's this?
Did you ever think you'd have a student that'll confiscate their own phone for themselves?
Maybe not.
What?
Let me just do this. An plus 1 on an plus 1.
What?
I think Liam's the one who's gonna be the MVP for the pizza.
Yeah.
What if I stops?
Solid is going to stop for 2 days straight and eat the whole pizza. Ugh. I have sleep deprived.
Oh,
Wait, are you sleep deprived? That's not good.
I think I've lost the ability to sleep properly.
Really?
I don't know why.
Did you
Sleep
eat too much?
quality. Since daylight savings, I've not. Takes me like longer to fall asleep now.
I stayed up to like reading English book for the
So do
So
you
when
wake
did
up
you go to
later?
sleep? What time did you wake up? What time did you wake up?
Did you get up?
What?
I forgot.
I swear, if I don't sleep enough, I get dumber.
Yeah, same. I just no more brain power.
You sleep later? Do you like wake up earlier or wake up later?
Later.
Oh.
Just wake up earlier.
Yes. The later you sleep, the earlier you wake up.
Oh, for me, doesn't matter.
But doesn't matter.
That means you can wake up before you even do it.
Oh, I do that sometimes.
Yeah,
not
I do that
necessarily,
all
yeah.
the time.
Wait, yeah. It's like,
Wait, Michael, when do you sleep usually?
Oh gosh.
Don't you like just not sleep? Because you respond to me at like 1 a.m. sometimes.
Yeah, then Michael bring me like an inspirational speech at 4 a.m.
Yeah, sometimes sleep does not bless everyone equally.
Stop blessing me.
Alright. Alright,
What motivational speech did he write you at 4 a.m.? Show me it.
Oh no.
so by our induction hypothesis, yeah? This equals that, right?
Yeah.
You see that? Because that's the kind of that's the last entry, yeah? And it's the last entry times the previous p plus the p before that. Right? Okay. And so you just need to rewrite this. See, because the an times... What is that? Okay, I think we should just simplify this ourselves, yeah? Let's simplify this ourselves. What do we do?
what? What's happening?
So let's get from this line to the end. We're trying to show this is equal to Pm plus 1 on Qn plus 1, yeah?
Why is it equal? It's kind of crazy how it just works.
Yeah, it's actually quite intriguing. Quite elegant.
I've heard a theory as to why your intelligence has been going down lately. Your lack of sleep.
Maybe.
I notice when I don't sleep, my brain, like if I start thinking, it just starts hurting. Because it's hurting, I can't continue thinking.
It just hurts. Actually, there was a period where I was keep getting these headaches.
Yeah, exactly. Whenever I don't sleep enough, I get headaches when I try to
If I
think.
don't sleep enough, my brain's just weak.
Yeah.
Yeah, sleep is very necessary. And the right amount of sleep, I guess, is important.
Played chess lately.
Oh,
For 3
no.
months.
What?
He hasn't been online for 3 months.
Oh, for chess. Yeah. It's because, like, we had this weird thing where, like, people wanted to see if I can get to 1900 on chess.com. And I did it, and then I kind of didn't know where to go from there.
I know
2000!
A lot of it is just, like, not blundering. Like, if you kind of can... And if you play a lot, you'll blunder a lot less.
Sir.
But then you'll notice other people blunder so much.
Sir, there's a very obvious next goal after getting to 1900.
Yeah.
2000!
But then, like...
What about not dropping?
Get 99.9 percentile.
Wait, 1900 is, like... What's that? 99 point something percentile.
I'm on 99.8.
Oh. You're like 1850, right?
1820 right now.
1820. That's pretty cracked.
Damn.
Like when I was like on like 1700, I thought that was good.
My friend was at 2100 and he dropped all the way to 1800. But then he pushed back up.
I don't know. There's a lot of variance because like if you look at some of those games, it's like they should not have been lost. Just time.
Had a chess.com account at 2500. They were not 2500 skills. But they did have.
Yeah.
And obviously they got banned.
But guys, how do you simplify this expression? I think Alex has already done this, right? Maybe Alex, you should skip to the like if you go into the document, you can skip to the part. Wait, how much did Alex miss? So we proved that. So just so Alex has something to do. So we did the root 3 and root 2 exercises, proving all the ways of getting the Pell's equation solution. And we also proved that, like that gives you all the solutions. We also proved that, there exists infinitely many solutions to Pell's equations. This obviously, like the other things covers that, but this was like a really nice argument. There exists, coming just from Dirichlet's lemma thing. And then we had like 2 lemmas. Basically, one was like anytime you had a solution, anytime you had something approximating an irrational. So anytime you had something approximating an irrational within 1 on 2q squared, 1 on the denominator, 2 times the denominator squared, it has to come from the continued fraction. Oh, that's this theorem here. Yeah. I think I sent you recordings, but I'm not sure if you watched them. So anytime you approximate an irrational number really good, it has to come from the continued fraction. So continued fraction is some sort of universal way to approximate stuff with fractions. Okay, and then we also showed the converse of so like, if you have square root of n, then if you take the period, multiples of the period, and you cut off the continued fraction, then you get a solution to Pell's equation plus or minus 1. Conversely, if you get a solution to plus or minus 1, it has to be a multiple of the period. So that's down here somewhere. I think you're in this document. No. But those are the things you missed. Okay, so we do that while you do the other thing.
Hello, small children.
Okay, let's finish off this calculation. So get from this, yeah, to Pm plus 1 on Qn plus 1. Yeah. Does that make sense?
Indeed. Why have my legs given up and working?
IMO intermediate.
So what kind of stuff can you do here?
Oh, yeah. Intermediate Maths Olympiad, IMO.
Yeah. Okay, so what do we do from here, people? We need to simplify this, yeah?
Dude.
Hold on.
I have no idea what the hell we're doing. I'm not incorrect, sir, and I'm older than them and not inferior to them, so I can, you know?
I didn't say the converse of that was true as well.
The converse is true.
You can't enforce that. It's kind of like respecting your elders. You can't really enforce that, you know, like...
Respect.
It's just etiquette.
Those two have no etiquette. Well, Alan has no etiquette.
What do you mean?
Look, be nice.
I'm being very kind. Could be
Uh,
a lot meaner.
yes. Go on, people. It's just simple algebraic manipulation. How do you manipulate this?
Algebraic manipulation. Let's go.
And he had solved this.
I'll make this nicer for you.
So what are we trying to show it is again?
Em plus 1 on Qn plus 1. But there's some things you'll do even if you didn't know what you're trying to show it was. Let me just write this with a fraction symbol.
What's going on in this document? Numbers.
What?
The weather looks more conducive to basketball today, sir.
More conducive to plus.
We won't feel like we're being roasted above a fire. Or below a
Why
fire.
do you do basketball again?
What?
Should we do soccer or basketball? What does David like better?
Basketball.
Alright.
No one likes soccer.
Exactly.
1 o'clock.
Soccer is like years old.
We should probably go like 2 something if we're gonna...
Basketball is also years old.
Because that gives us a good... Basketball is like much better than soccer.
Liam's just saying that because he has the advantage.
Exactly.
Because he lost the bet in soccer but won the bet in basketball.
Exactly.
Yeah.
How about we play soccer?
You're being outnumbered like 3-1 here, Alan.
I don't think you understand. I think he suggested that just because you didn't like to do
Yeah,
that.
I know.
Uh-oh. A little format.
Alan, there's something wrong with the sentiment of just doing
What
that.
is going on with that bracket? A little bit incorrect.
What the?
Inside the thing.
What
It should
just
be like
happened?
outside all of that.
What?
Michael's posture is
Yeah, this is that thing.
This thing here, right?
The brackets in parentheses on the inside.
Oh!
What the?
This is
I've
very
got you,
slow.
sir. I'm here for
It
you.
should be that.
No need for concern.
Whoa. What the hell?
I'm not gonna say
What's going on?
Sir, I believe in you.
What did I even copy and paste?
I don't know.
What? I just copied that stupid thing. I didn't want to do that.
This is why I use TechMax.
What's TechMax?
Okay, technically it's Morgan, but
Is it the thing Evan uses?
Oh my gosh.
Evan uses it.
What's TechMax?
This
Wait, does it update while you write?
It's just like I'm just editing.
Oh.
Right.
Ooh, that actually seems cool.
It's like typical
what?
conventional.
We're gonna clear the denominators, yes?
X equals.
Clear denominators? Algebra?
Ooh, that is actually good.
You know what I'm saying? Like it's algebra.
I get that. Does that work on Mac?
Just times the top and bottom by AM plus 1 and then go from there. Yeah.
But
Times top and bottom by
works on
AM
Linux,
plus
it
1.
probably works on Mac.
Yeah. There is a Mac. Yeah, there is a Mac.
Isn't Mac based off Linux?
No.
Oh,
It's based off like some kind of BSD.
Well, what's this? What's
This might
going
also
on?
be a code. I don't know. I'm pretty sure it has a Mac. Most people are using it. But more people are using it on Linux.
Yeah, so the first step, maybe just clear the denominator, yeah? I don't know why this is still circled.
So,
Okay. Okay, there's some typos here
there's a notable typo.
to distract you. So that...
that is why that was an error. I think the cool thing about TechMax is it matches the brackets. It's pretty interesting. I don't know how exactly it works. Let me check the actual file.
Ow. We should expand the brackets, sir.
Oh, that's not a bad idea, yeah. Expand the brackets.
Expand.
Alan, I can literally pick you up with one hand and chuck you off the balcony.
Bro, he
What?
clapped at
Are you threatening to kill one of my students?
No, I'm just stating a factual statement.
Like, you could do that.
I
Yeah.
just clapped at you, Liam. And that's a factual statement.
Why are there so many people who just enjoy annoying me?
You know what's sad is you don't enjoy annoying some other people, but they get annoyed and it's annoying. If you got enjoyment out of it, then it would be fair, wouldn't it?
But, like, I don't really enjoy annoying people.
Yeah.
They're enjoyable.
Yeah, actually, I don't know why Alan enjoys annoying you. Alan.
If only more people could be like Alex. Yeah.
What has been done here?
Yeah, it does keep track of it. What is going on here?
Something doesn't look right.
What doesn't look right? Let me look.
Hmm.
Pn minus 1. An.
Could this be a PN minus 1?
It looks right.
But
To
Michael,
me.
how's Pn plus 1 defined again?
Yeah, it looks right to me.
Huh?
What's the definition of Pn plus 1?
PN plus 1, the definition of PN plus 1 is AN plus 1 times PN
Yep.
plus
And
PN
if
minus
you
1.
continue to expand it, you will see something.
Wait, should this be an N minus 1 here? Or an N?
But
Yeah, that's good.
I've got an idea, so multiply it out. Like, just multiply it out. That seems prudent.
N plus 1. I'm starting to worry. Okay, so what is... So this thing here, it should be times the previous p, right? So the previous p is n minus 1, right?
Yeah.
This should be n minus 1. Okay, now I think I know what to do.
Alright.
So the previous p is n minus 1. And this is n minus 2.
Jeez. Alan is a cheese.
Classic.
Okay, so now we should be able to do it, okay?
Due to the cheese name.
I just squeezed it from the outside.
Okay, so for example,
It's like a very medium.
can you see that an times
Yeah.
pn minus 1, right? Plus pn minus 2,
Yeah.
that's just equal to pn, yeah?
Yeah.
You see that?
I can
So
see that.
an
Ooh,
times pn minus 1 plus pn minus 2, that's just pn, yeah?
This is looking promising, sir.
Okay.
Leo, when were you born?
For you. Correct.
These
The difference in maturity between David and Alan is stark. As we can clearly see, proof that taller people are more mature.
Yeah, I don't think that's true.
Huh?
Seeing us.
Correlation, causation.
Yeah, yes. Well, there actually might be some correlation between that, because being taller would probably mean you're more physically mature, which could hint at you having more. So it does actually make some sense in terms of
Okay, revised calculations.
Alan is probably genuinely just less developed than you. Like that's it.
Well, I guess he's melted.
Like this.
Oh, that's what we wanted, right?
Yeah.
We did it.
What the? How did I end up over here? Number 2.
Number 2. 2 number.
Are you down?
Q plus 1. Yeah, so stating things in the right generality is important for induction. Why is it doing that? End group missing. Begin aligned.
I'm gonna be honest, sir. The content in this book does not match the Olympiads it's targeted to.
What do you mean?
It feels like, especially number 4, goes beyond what's required in AMO.
Yeah, this is to senior as well.
True.
Wait, why is there a closed bracket missing?
It's like,
It's just not showing.
It's something I can't do right now.
Indeed.
Yeah, it's a fucking book.
Children. So,
Oh, there's like a random fraction thing here.
well, I could believe that.
Wait, how old are you though?
Oh, I'm 12.
Okay, now it's right, yeah?
Yeah.
Okay, so then this makes sense of this kind of like trick where see usually you have a normal continued fraction, right? Because normally they're infinite, yeah? They're infinite.
Yeah.
And then you have the finite bit, which are all normal continued fractions. Then you have the tail as one of the things, right? And so then you can write the number itself as this. See? Which is actually not as obvious as you think, right? Because like you write root 2 equals 1 plus blah blah, right? Like, but is it actually equal to that? You know, like you have to make sense of a limit, right? Because like one expression doesn't even really make sense, and the other expression is root 2, right? So it's really the square bracket thing is equal to that, and then why is the alpha equal to the square bracket thing in the first place? You know. Okay. Yeah, I mean, you can maybe try and prove this as an exercise at home or something. But this is a very important result. And not very difficult. So for example, this shows you the P's and the Q's are coprime. Okay. It also shows you how to solve but it shows both how to solve like the linear differenting and the Pell's equation. Okay, because this is essentially kind of like ax plus by equals 1.
Did it done?
Yeah, it's done.
Yeah.
Okay, so now we can move on to geometry.
What? Geometry. Oh yeah.
So we actually probably do need k equals 3 as a base case.
Yeah.
So,
I don't know anything about it.
There was a problem that Evan Chen was not able to write a walkthrough up, so he basically just wrote the solution and asked you to tell.
walk through yourself.
It was like, why does this solution work?
I can only show you the door. You must walk through.
It also was like one of the 2 hardest Olympiad problems like ever in a competition. One of the 255 M's. So,
I mean, there is like a problem-solving technique where you literally just like you solve the first problem is either the hard problem. You have to literally just solve a hard problem, right?
yeah.
Or you're doing something and you know it's the solution to a hard problem, right?
Mhm.
And then you look for all these other problems for which it's the solution of. And so, you're not solving. You weren't actually working on those problems, but you've solved them.
Yeah.
And so it looks like you've solved a ton of real hard problems. Because like if you ever worked on a specific problem, it might be impossible because you don't you know what I mean. But if you have a solution to something and you try to match it to a problem, like
I have in fact solved many hard problems.
yeah.
Yeah.
Look at the man go.
You know what you should do to put in this book to torture some random students because it'll be funny? In the combinatorics part.
This sentiment is what you don't like about him.
Yeah, no, but this one will be fun. You know how you have a Combi game section, right?
Yeah.
There's this Combi game question from USA TSTSD that you should put in. The NIM style game.
Okay.
Oh, hey.
Alright, so this is actually giving me kind of flashbacks. Okay, check this out.
Recording in progress.
So this is this is kind of a famous handout, okay? Which is like 3 lemmas in geometry. Okay? I literally remember doing this with Hai Bing, Jordan, and Edwin when they were like in year 10 or 11.
Oh, yeah?
Okay. But it's kind of crazy because like all this stuff seemed kind of pretty weird and hard at the time.
Obvious, isn't
But
it?
now this is all like super well known. Okay.
It's obvious.
Okay, but the thing I want to focus on, the one I want to focus on.
Spirals.
So
Bam.
what was it? The first one was like the in-circle, X-circle dilation, which we should do at some point. The second one was spiral similarity, which is essentially like 2 circles intersecting. But this is the one I thought.
Symmedian.
Symmedian. It came up a lot yesterday.
There's a sine law, Chase. God damn.
Okay, so do you guys know what the claim is? So the thing is, a lot of these things I kind of bailed us out with complex bash. But the thing is, we should have synth for everything as well. Okay. So what is a symmedian? You know what a symmedian is? So the median is like it goes to the midpoint, right? So median is the vertex joined to the midpoint, or like that line. Yeah. The symmedian is the reflection of that line about the angle bisecting. So it's on the other side. Yeah. So the angle that the median makes with one of the sides of the triangle is the same as the angle the symmedian makes with the other side of the triangle. Okay? Alright. And the Symmedian Lemma, okay, is that instead of reflecting about the angle bisector, right? If instead you do the tangent, you intersect the external tangents to the circumcircle, yeah? And you join that point to the top. Then that dotted line is the symmedian. Yeah.
How is this possible?
Isn't this literally what you used yesterday?
Yeah. That is crazy.
So, like, I think the proofs that we usually come up with are like some sort of trig, and
I came up with
complex bash.
Harmonic proof.
Yeah, so here there's some sort of harmonic and there's some sort of angle chase. Okay, I thought it'd be interesting to look at those.
Sine law chase. Hey.
What the?
Yeah, I think sine law chase maybe you should do it yourself. The second proof is kind of what I'm after here.
Oh.
Let me just put this diagram up. So circle.
So they had a diagram up there. You can copy it, right?
Yeah. Just did.
No, that wasn't the diagram they used for the second proof.
Oh really?
No, scroll up. They used that diagram.
This one.
Yeah.
Ooh.
Oh.
Actually, how about this? Let's just look at the diagram and see if we can find the proof. Yeah, that might be a better exercise.
Okay.
But we don't know how these points are defined.
I think it should be pretty obvious how these points are defined.
Oh yeah, that is true.
Okay, so now what do? We take P and Q, and D should. You want to prove D is the midpoint of PQ, I think.
D is the
Wait, no
midpoint.
shit, it is.
It's the center of the circle. Yeah.
It's done.
Huh. Okay, so
it's just done there.
wait, it's kind of like the G4.
Yeah.
Okay, so you can see how things are defined, right? Like you draw the same diagram, but then you make a
crazy,
circle
what?
centered at D, going through B and C, right? Then you
Oh, it's literally G4.
and then you extend A, B to P to hit the circle, right? And then AC to Q to hit the circle.
Anti-parallel to Q, right?
Yeah. You do have to prove one more thing, which is that D actually lies.
D.
That's the only
M
thing
is the midpoint of BC. O is the center of that circle.
That's the only thing you have to prove. Okay, so are we defining PQ as A, B intersect the circle? Or are we defining P as... Okay, well, we're defining it like that. Now we just need to prove P, D, Q, Q. Alright, how do we do that?
If you say Pascals, I'm gonna like faint.
Nah, I don't see any Pascal in there.
It'd be funny if Michael fainted though.
The man just dies of cringe.
The closest I was to fainting was when this guy made me do this weird drill where I'm just like jumping up onto a bench. You know, like the park bench?
Yeah.
You like stand below and then you jump up onto the park bench, jump down, jump up, jump down.
Jumps.
Yeah, maybe that's what they're called.
Like this.
And see how many you can do in 60 seconds.
Oh.
I almost fainted.
What the fuck? Screw top. How do you speed runs?
Like, what the fuck?
Okay, I hope none of you faint.
The closest I've ever come to fainting was some random time when I stood up.
Oh yeah, like when the
You have to
like,
be
the
precise.
brain was so yeah, that thing. It's so annoying.
Okay, well then, in order to do this, we need to prove PCQ is the right angle or something like that.
PCQ. Oh yeah.
How do we prove that? Oh. Why is it a right angle, bro?
Because it's still going.
Maybe we can do a little...
Midpoint to midpoint.
Why would it? Why would it do that? Maybe we could use the fact that OM and D are collinear. Cool. Is D reflected about... Wait, is DM equal OM or is it not true? Or am I capping?
DM equal OM? No.
Wait. Is it true? Oh, wait, no, it's not.
No, it's not.
Not quite right. It's not quite right. They are perpendicular. OCD is 90.
Yeah.
So, now I just need to prove. Okay, so we have that angle. We just don't have PC. Anything to do with PC. What do we do with PC, bro? PC. We have PVC. And we have BP. We don't have BPC. Ooh. It's PC. That's just the tough part. BCQ. They should be equal. Wait, can we do an indirect? Not right. That's tough. This is not by no means done.
Is this problem literally G4? Wait.
Not really. Wait, is it? Hold up.
Wait, it could very well be just G4.
Wait, did they just tell us to prove G4? No. I don't think so.
Let me check how G4 was defined.
Right, let me try. So I'll try to remind you G4.
Yeah, because this may well be literally G4.
So G4 was like this circle.
This is very similar to G4, but not quite. I need to use the tangent condition. That is what I need. That is the thing that I need to complete the proof. I know the angle of B and C with respect to each other. That is the key. Oh, then I know everything relative to each other. Don't I? I know P relative to it. Okay, I think it's just an angle chase right now. I think it's just an angle chase.
Oh, what? Where? What? Huh?
I think it might.
What are we angle chasing?
I'm just trying to prove like PQ's diameter.
Oh, okay.
Is a diameter. So I just need like PZQ is 90 or something.
PCQ.
And I think I can just angle chase. That might be interesting.
PCQ is 90.
Wait, how do I get this? So I need to. So we have BCQ as 90 minus C. So now I just want. This is actually not that easy.
BCQ is 90 minus C.
Oh, okay. BPC is 2 times BD. Oh, that's how you get it. Okay. I think it's just angle chasing. It's
So
just
that's
angle
90.
chasing. It's just angle chasing. Literally just an angle chased on here. Yeah. That's crazy. How did I not come up with that?
So the angle he's chasing, he's talking about.
Oh yeah.
How did I not come
He's
up
trying
with
to show
that?
P, C, Q.
I guess I just didn't find the inspired construction. Yeah, I just didn't find the inspired construction. So I just did. Okay. Yeah. Okay, it's just angle chase. Alright. Very nice. So, just need
So
to...
is the question just to show that this angle here is equal to this angle here?
No. But it's a show PCD equals OCA, right?
PCD equals OCA.
Yeah.
Why?
Because
What is the purpose of that?
we have this is 90, right? That thing there.
Yeah.
And if
I
this
see what you
equals this, then this is 90, so this is 90.
So we want to show that.
But what about what I said?
I mean, everything works. Everything works. It's literally just angle chasing, so everything will work.
Yeah, but his angle involves drawing PC in there.
Yeah, but I think you need to draw PC.
Your angle doesn't.
I'm pretty sure you need to draw PC, but like,
Like, does
if you want to prove it.
I don't think
It's all good. I think I got
Wait,
it.
does my thing not do it?
your thing does not do it.
I think I got
Your
it,
thing
bro.
isn't-
Oh,
true.
oops, it's not even the right thing.
Your thing is completely incorrect.
I got it, bro.
Alright.
It's all good. It's all good.
It's all good.
Okay, so you're trying to show this angle here is equal to this angle here.
Is that a similar?
Okay, BPC equals half BDC equals half times 180 minus 2 times A equals 90 minus A. This is very AIDS. Okay, I don't know. Is that the best? I don't know. I'm trying to find the cleanest way of angle chasing this, even though I know that it's definitely angle chaseable.
Is the person that is talking a lot and sounding smart Liam really Liz?
Who said that?
Probably Alex.
How would he? How does he know who I am? What the fuck?
And then,
I don't think I've told that kid.
okay, I'll just write it down. I'll just write it down. So angle BPC
Loud as Liam.
half angle BDC. Do I want? Do I? That's the question. Do I want? I go. I want it. I'm doing it. BDC equals half 180 minus 2 angle A equals 90 minus angle A. So therefore, here we have BPC now. Yep. Okay, and that does it. Okay. I think I got it.
Alright, what about other people? Should we...
I got it.
Did you show the red was equal to the green? Alright.
Damn, that's crazy. You just needed to construct like 2 points which were not actually out of one of these because. So I guess it's understandable that I did not manage to prove this without harmonic bullcrap. Because this is actually pretty inspired.
Yeah, I guess the thing about this is, so like this angle being 90,
Yeah.
or this angle
I
being
proved
9
that
doesn't
that
really...
angle's 9.
The top one?
Yeah.
Because it doesn't...
Okay, is there a cleaner way? I need to find a cleaner way. Because clean is good.
The 2 circles are intersecting. Yeah.
There's 2 circles in a second. What could happen here? Ooh. This is tough. Yeah, I guess that's a little bit clean.
Oh, so the circles are like they're
Little
both
marginally
they're orthogonal circles.
What did I? That's annoying. Because currently my angle chase is a little bit rough. Yes, actually no, it's not the roughest thing. It's like I would hope for it to be 2 steps, maybe 3. Right now I'm like 4 steps. Get it down
Collinear.
down to fewer steps. How do I get it?
Oh, could you invert this?
Could you invert?
Because
Maybe.
like, if you invert about A,
A. Oh.
like wait, actually, hold on.
Root BC inverted by A.
Wait, maybe not A. Wait, what?
What the hell? Yeah, I don't know what D goes. It's like D just goes somewhere random.
Yeah, maybe like invert about O is where D would be controlled. Then B and C get fixed.
If invert about O, D goes to M, and M goes to D.
Yeah.
So then what happens? I don't know.
Is the radii of the circle equal?
Radii of the circle.
DBC.
Right, isn't it?
What? Wait, hold on. Nah, wait, does D go to M?
The circles are orthogonal. The
Circles are
radii-
orthogonal. Wait.
You claim that the radii are equal?
No, if it is,
Oh, this may be a road to a
moving
clean
AC
inversion.
to PC
Oh.
is in the same ratio as the radii to each other shows it.
So OC is tangent to the other circle.
Something is cooking. Don't know what, but something is.
And DC is tangent.
We invert about the circle stuff. You get D goes to M, right?
Yeah.
Yeah.
D goes to M.
The circle. Nah, that doesn't really help. No, what I really want is where P goes, which I don't know. I don't know where it goes. Okay, maybe that wasn't the best idea. What about A?
Yeah, if you know where A goes.
What about reciprocation?
Oh yeah. Alex investigates those while we angle chase, okay?
Alright, but then I don't know how to define P and Q. Cool.
Alright, team.
How does
Alon.
similar switch work
Damn.
again?
Similar switch.
Yeah. Because if it's true, then PDC is similar to AOC.
Yeah, you're claiming that POC,
PDC is similar to AOC.
PDC
Yeah. Because if it's
is similar to what?
AOC.
AOC.
Okay, actually, yeah, my angle chase is like 1, 2, 3 steps. It's 3 steps.
Like that, right?
Yeah.
3 is 4 steps technically, but like 2. Can I get the number of steps down? And also, does reciprocation? I don't think it does, honestly. There's another circle. I don't know what happens to the circle. The circle becomes some weird thing. And I don't think reciprocation is the best idea.
What if instead of those triangles, Liam, you took like these triangles? If instead of those triangles, you took these triangles.
Oh shit, I just proved it. A lot of things that were not. What?
It's kind of weird. Like, it feels like assuming that the angle is 9 degrees there makes a lot of sense.
Assuming the angle's not. Wait, where?
The red angle.
What if that solves the problem?
Yeah.
Ah,
Because now, like, you can draw this diameter here, right?
yeah. Wait, how's that?
Are they similar? So, is that a standard similar spiral similarity?
Yeah, I don't know if you can get spiral similarity. Spiral similarity requires one of the intersections to have two lines going forward, but we have one tangent which is not good. One tangent.
Is a line doing this angle chase? Let me erase this. So we're trying to show that this angle is 90 degrees. We're trying to show this angle is 90 degrees, yeah?
Wait, the similar switch is actually good. Hold on. Well, it's just a minute. This similar switch might be good. Even though it's degenerate. Wait, I think the similar switch works. Hold on. The degenerate similar switch does work. Wait, what the fuck? Wait.
Alright, we're gonna have to investigate both of these.
So cussed. Okay, well, it's an angle chase, so it's like anything. Everything works. You can do it however you want.
Yeah.
Okay. Yeah, I guess if you think of alternate segment theorem as just degenerate exterior angle, then the similar switch works.
Yeah.
Yeah, I don't see what the mini Mikkel config that Lucas was talking about is in here. Like, there's no such thing. Not knowing what he was talking about. Wait, do we know that PQ is a straight line?
PQ is a straight line. We don't know. We don't know. We don't know D lies on.
on PQ.
Oh.
Yeah.
That's what we're trying to prove. How does degenerate symbol switch work? Maybe this is what we're looking for. Like, this thing's tangent. And then that thing is like that. Okay, so now... What is this? This is a cuss. What? It's like this equals this. Oh, so you do get that. And then that equals that. Okay, so it's still like basically the same. It's basically a similar switch. Is Liam successful?
Oh, what are you doing?
Wait, if you it looks really similar to G4 if you draw in BQ as well.
Yeah, but this time we're not given it's a right angle. We need to prove it's a right.
It's
Yeah.
like a converse.
Converse of G.
Is that really what it is?
Maybe.
We'll investigate all of these things, but we should really be able to angle chase this. I feel like
So maybe I can solve G4 now.
I think this problem literally.
I'm going to solve G4. Just watch.
Alright.
Hee ha. G4 is being solved. So now I just say this is cyclic. Then I say, oh, but what is this? I solve G4.
Wait, this problem is G4.
Okay, so G4 doesn't require complicated things. It's just angle chasing. Lemma. Trust me, bro. It's just an angle chase. You can do it. So how would you do it? You need to label all the angles.
I'll start labeling some angles, guys. Alright. So I'm getting flashbacks. Let's label some angles. Maybe call this one.
So this is the non-Lucas solution of G. The one that actually makes sense. And also the one that teaches you how to prove Symmedian.
Call this one beta.
Also, you need to remember all of the information you are given in the problem so you can use it. What information are you given in the problem?
What information are we given in the problem?
Like, just go through every point and figure out how it's defined.
Tangent.
Do every point.
Oh, does the midpoint? I don't think that does anything. In
M is irrelevant.
irrelevant in this.
Yeah.
It's only relevant after you prove. Once you proved it, okay. The point is, like, once you prove that it's collinear, right? Then.
And it's the midpoint because.
Right. So the whole point of the M thing is because, like, the triangle ABC with M as the midpoint is similar to AQP with D as the midpoint.
Proving Symmedian.
And it's similar by reflection, and so the median turns into the Symmedian. So this is the median of the reflected triangle, and so it's the Symmedian of the original triangle.
G4.
So the M is irrelevant, but Yeah. We could probably also remove. Can we remove D? Oh.
Probably.
Can we remove D?
Can you? I mean, D probably doesn't matter.
It doesn't matter.
that
So
much.
the diagram only depends on, okay, so it's a circle like that.
Yeah.
With the center there. AB.
I don't know. D matters a bit. Not. Actually, it doesn't.
Actually,
It does matter because you want D for the OCD. For the
Yeah.
OCD right angle, which you know.
OCD right angle.
Yeah, you already know that. Yeah.
Yeah, okay, and then
You
also
need
that
D
you
to help
know
you
that
with
they're
that.
all isosceles, but you just don't know that's collinear. Maybe just prove that's collinear.
Yeah. I mean,
So here's D is the center of the circle, right?
Yeah.
It goes C to B is tangent, and then to P, but you don't know it's like to Q. It's collinear. But I guess you can find a lot of these angles. Yeah, like you can literally just find all the angles. Like actually, if you just find like this angle
yeah, exactly.
and that angle,
You can find all angles. So there is no problem.
yeah. Yeah, maybe marking in a specific angle was a little bit too pressurized.
Yeah, it is very simple.
Like if you know this angle here, let's call it alpha, yeah? And call this angle like beta, yeah? Then you can basically get these two angles in terms of alpha and beta, right? Is that right? So this angle here is like 90 minus alpha, yeah? I'll call it alpha bar.
Alpha bar.
And this is beta bar, right?
Yeah.
Yeah. And the top is alpha beta, yeah?
Yeah.
So can you see that? Can you see what this angle is here?
Is it clear what it is?
2 alpha bar plus 2 beta.
Alpha bar.
Wait, if you're using alpha bar, I'm worried. Wait, unless you're... Because we're doing we're angle sum of quad, yeah? Are we? Or how are you getting it?
No.
Huh?
No.
Cyclic quads.
What's cyclic quad?
Oh,
Just quad.
yeah, just quad.
Just quad.
90 angle sum of quad.
Quad.
Angle sum of triangle.
Triangle.
Yeah. So there's like 2 alpha, 2 beta, and 180, yeah?
Yeah.
So then this is 180 minus 2 alpha minus 2 beta,
Yeah.
yeah? And then here this is 180, this is 180 minus 180 minus 2 alpha. So this is just 2 alpha, right?
Yeah.
This is 2 beta. And so it's a straight line. Okay, so now I'm curious about the similar switch thing. What did you do?
No, it's really funny. Okay, so you know how the similar, like the two circles intersecting?
Yeah.
Crap, you have like... Okay, so my goal is to prove PCA is 9.
PCA is 90. Okay.
So I did a similar switching on this triangle PCA.
PCA.
Yeah, I guess if you try to similar switch it, you have to look at the vertex B. because that is the place where the two lines intersecting or the two circles intersecting diagram.
Mm-hmm.
Okay. The other line passing through B that isn't just BC is BD.
No.
So you draw BD and you extend it. That's
Wait, David, do you know what similar switch is? Okay, you asked about this. I think you might have missed the class with this. So,
yeah.
similar switch is okay. There's two things. So similar. There's a thing called a spiral similarity. Okay, so you have two circles intersecting, yeah, and you have like kind of like a line that passes through one of the points of intersection, yeah. And then what you get. So what is a spiral similarity? It's just a rotation plus a dilation. Okay, but what I'm trying to claim is that always happens when there's two circles intersecting. So what happens is at this other, and it always happens at the other intersection point. So like, if you draw this triangle like this, and I think that it probably goes to this one here. Yeah. The claim is these triangles, the red triangles, are rotations and dilations of each other, so they're similar. Okay, so for example, you can see that this angle here equals that by bow tie, equals this one because vertically opposite, and it's equal to this one by bow tie. So it's the same angle at the rotation, and then like you find some other angle that's equal, like this one equals that one, which draw the point of intersection here. So this one's equal. This angle here. Oh, let me draw this. This angle here is equal to this angle here, which is equal to this angle here, right? Because it's like bow tie and then cyclic chord. So then those two triangles are similar. Okay. And so whenever there's two intersecting circles and like lines going through the other point of intersection, so here we actually started from, I guess, the similar triangle. And what's similar switch? Similar switch is when you have a pair of red triangles that are similar like that. Okay. You can always switch them to get another pair of triangles which are similar. It's these ones. And now the blue triangles are similar. And they're also rotations of each other. Okay. Yeah. And you can show that pretty directly. Alright. Alright, back to this, Alex. What are you saying?
Yeah, and then, like, I guess if you look at it, it's kind of degenerate, because usually the blue line should intersect the circumcircle of ABC again somewhere.
But it doesn't.
Yeah, but this is tangent.
But it's not, so that point is actually just B.
Okay.
It's just B.
Okay.
And then the other point is where the blue line intersects the circle, so that's like
minus B.
That's diametrically opposite. So if you have a look, then BC minus B is the triangle.
Oh. So he's trying to say, like, so, you know how we have the blue lines intersecting at one of the points of intersection? Yeah. He's saying this blue line is one of those, and that green line is one of those. Okay, and then the similar switch happens at C. So the red triangles that we're getting, okay, would be, would be like this triangle, alright, plus
like CP minus B.
CP, like that.
Yeah, but I think you need to use similar switch. Just yeah. You don't need to use similar switch necessarily.
Oh, so this is a straight up spiral similarity, right?
It's just spiral similarity.
And so that straight up gives you that.
Now you get ACP equals BC minus B, and BC minus B is obviously 9.
So you straight up get that this angle equals this angle, right?
Yeah.
Oh, which gives you 90, yeah. Yeah, so then the ACP is the similar switch of BC minus B, right?
Mhm.
Yeah.
Yeah.
And like obviously if this angle is equal to that, and there's the same in the middle, then when you add the middle part, they're still going to be equal. Okay. Yeah. Okay, so the Symmedian thing is true. Okay.
Yeah.
Whoa. First time I've seen a synth proof.
Then you have
Yeah.
Lucas's Mini McWell.
I don't know what that means.
Okay, and then we get on to the next thing. I guess 3 lemmas are a bit dated. That's why then there's a whole book full of lemmas, right? Literally, the textbook is lemmas in Olympiad geometry. It goes for like 300 pages.
I need to zoom out. So
There's a little bit more lemmas than 3.
just
Alright.
a recommendation.
No, it's okay. So,
Should we do G4 now?
oh yeah, G4. Okay.
Yeah. I done it.
Right, let me
Isn't
try.
G4 literally Symmedians, but they give you that it lies on the line.
Now that I'm on with the synth proof of Symmedian, I can prove
Recording
G4
stopped.
without using any theory.
Okay, do you guys remember what G4 was? So it was like this.
Recording in progress.
So David might recognize. You have a circle. Ugh. No. I have to sign out and in again. It's not good.
You have to click the X.
To expose my email address again.
Oh no.
This was funny at the time, I assure you.
Big baller, bro.
There was a brand called Big Baller Brand. That just went out of fashion though. But my email address didn't change.
So
Okay.
you're just gonna be stuck with Big Baller Brain for the rest of your life.
Yeah.
Baller.
It's like as my brain shrinks, my email will still be called Big Baller Brain. Okay, so I have this thing here. 90 degrees. And I have something here and 90 degrees here. So it passes through that point. There's a diameter. And then this continues on to here.
Yep.
And this continues on.
Good.
This is called
Wow.
P, and this is called Q.
Yeah.
Okay. And I forgot what these other points are called, but oh yeah, this is called E. This is called F. This is called D. Okay, and then you have some tangents at D and F, which meet at B. Okay. A tangent at E. Yeah, like the original question was like a triangle ABC with incircle this, but it's the same as drawing the circle first, which makes a lot of problems easier. And the claim, so it's you're given that these are 9 degrees, okay, and the question asks to prove that B is the midpoint of PQ. Okay. So it looks very much like the converse
Yeah.
of what we just did. So what did we just do again? So we have like something circle, tangents. Yeah?
Yeah.
And then it was the midpoint of like that, right?
Yeah.
Provided that it's like these just intersect, right? Oh, wait, so that means for G4 you could literally draw a circle from B
Yep.
Wait,
to
that,
P.
that literally
Oh.
shows. Wait, that trivializes it ridiculously much. Because. Yeah.
So basically, you have to show that. So you know that PDFQ is the cyclic.
And you know that
Now you want to show that B is the center of this.
Yeah.
So how do you do that? Use the angle chasing.
Oh.
Draw the circle PDFQ.
Oh, is that what you want to do? Guess there's a few approaches to this.
And we just need to prove B is the center.
Prove B is the center.
Yeah.
Uh-huh.
But draw like BQ and BP.
BQ and BP.
Yeah.
BQ and DP.
BQ and BP.
Okay.
Yeah.
So somehow that is collinear.
We don't need it to be. We just need to know
Alright.
FB equals BQ or
FB equals
something like this.
Yeah. So it's actually like it's like a direct consequence of what we just proved.
Yeah. I just started different. But no.
Because like the thing that we proved was like
Yeah, I don't know. I did something pretty simple. Very simple.
but you mean you didn't draw the circle?
I didn't have. Yeah, technically you don't have.
I don't like when Liam suggests an idea and then looks away because then we're stuck with
And
his
then we
idea.
have to figure out what
See?
Liam wanted.
I know. I just have no idea how to execute the idea because I'm like.
Because you're on your phone. Because you're on your phone.
That's great.
It's on your phone.
He's not trying, so he can't do it.
I can't geometry without it.
Wait, were you just typing sadly I'm dumb and it's geometry, so I'm very unlikely to say something of value?
Well, you see that test.
See.
What?
Bruh. Okay. I don't know, I just did very simple. I try to prove B is center of this.
Yeah.
Yeah.
So there are ways to prove that B is the center of this.
Yeah, that's literally what I'm suggesting.
So we know that DB equals FB.
Yeah, we just need to prove FB equals BQ or some one of those.
I don't know, I found DB.
DBF.
DBF. The angle DBF.
Yes. You find it done.
Oh yeah.
Why is that, Liam?
Wait. I can see why that would be.
Why is that Liam?
Why is it,
Why
Liam?
would it be?
Why would it be? Yeah. So you're saying if you find this angle, you're done.
Well, in terms of the other shit. How would you find this angle in terms of the angles, the other angles? It's basically reverse reconstruction.
Well, I basically see what. Something paper to work for that. It does. But wait, so if neutral center of EFD.
What? Why?
EFD.
Yeah.
Why is he doing that sentence?
It's just making it difficult for me.
Can you?
But why is he
trying to
doing
not draw on the.
And then D, F, and then connect D and F to that point.
Okay.
So we know we need to prove that EPF is half of that angle, right? Half of DBF. And we know
EPF.
the angle D center F is 180 minus D center F is equal to DBF. And half of 180 minus that angle is equal to that.
Actually, we'll call it I.
So half of it minus 90 is EPF, and that's half of DBF. So that doesn't. Yay.
Wait, what are you saying? So you're saying the green dot is half of angle DPF, or double angle DPF?
The green dot needs to be double DPF,
Yeah.
right? And we know that the green dot is half of. No, the green dot is 180 minus this angle.
180 minus the angle at I?
Yeah.
Because of the tangents
Cyclic, yeah.
are 90 degrees?
Yeah.
Okay.
And then we know this is half of the angle at I.
Okay.
So, and this is 180 minus I, and this is, because of the 90 degree there, this is 90 minus half of I.
90 minus half of I.
Because there's a 90 degree there, and this is half of I.
Okay, so you're saying the angle at E is 90 minus green dot on 2, yeah?
No, it's... Oh yeah, 90 minus green dot on 2.
And then this angle is green dot on 2, because it's got it's 90
Exactly.
minus that. But is that enough to show that's 90?
Yeah.
So now we need to figure out
Because
why is it that. So we had that the angle at the center is twice the angle at the circumference.
Yeah.
But if the angle is twice the angle at the circumference, does that mean it's the center?
Yeah. Does it?
Actually, it does not mean that, but we do have one more piece of information, which is dv equals f. So.
Oh yeah, that, yeah.
But that is necessary for it. But once we have that, does it work?
Yeah. So in general, like if you only have the angle, you have a whole circle of points for which the angle is true, right? But they're not all at the center.
Yeah.
But yeah. Can you see that if we construct the circle centered at B through D and F, because we know D and B equals F.
Yeah. So if you had
Q has to be on it.
So if you have like this line here, right, this interval, then the points which have green dot make a circle about this interval, right? But only one of the points is the center, yeah? And one way to determine the center is it's like on the middle there, right? But it is on the middle there because it's got the D and the D and the F tangents. Huh. Wait, so it seems like, could you prove it as a direct consequence of this configuration? Like, could you prove it assuming this?
Just assume.
Yeah, like assuming that...
Only assuming that.
So this is like an independent, like a...
Only assuming.
This is like a self-contained proof, right? Inspired by that, yeah? But is there a way to actually, like, this is kind of like the converse of that.
How would we do that? I don't know.
Like, for example, if you extended P, right? Oh, crap. Like, if instead of stopping at P, right? Wait, is there only one circle with radius B and going through those points?
Yeah.
There's only one circle, right?
Yeah.
So that's actually the same circle as this one here, right?
Yeah. Literally the same diagram.
Yeah.
It's the same circle.
Except you have to prove that the same diagram.
Yeah. But are they the same diagram? Well, So we don't have the 90-degree thing, right? Yeah. Yeah, so like, so the difference is like if you started with this like if you did this diagram, then so in this case you discover like that's 90 degrees, right?
Yeah.
Whereas here you start with this 90 degrees and you discover that B is the center of the circle, right? So usually when that happens, you can actually prove one directly as a consequence of the other as well.
Yeah.
So you could do it something like, yeah. I think it's like it's basically on this diagram you figure out that's P, right?
Yeah.
And you figure out that's Q. And so it actually is the P and Q in that diagram.
Yeah.
Yeah, so they're actually like equivalent problems, yeah?
Yeah.
Okay, so we're quickly running out of time. I wanna...
Recording stopped.
So the thing I really want to do is this thing, and hopefully you can kind of reconstruct everything else. But we had this idea of a pole and a polar, right? So
Recording in progress.
so a pole and a polar,
Yeah.
right? So maybe instead of telling everything today, we'll just give you something to work with. Okay, you have a circle. Okay, if you have a tangent that meets here, we call it point P, and we have the center like this. This line is called the polar of P, and P is called the pole of that line. Okay. There's more significance to that, but we probably won't go into it. And I guess we also know that this point is it's also known as the inverse of P. P prime happens there. Okay. So that's one thing. Another thing is the idea of harmonic. It's a cross ratio. Okay. So if you have a straight line and you have 4 points, okay, you have A, B, C, D, okay. So the cross ratio A, B, C, D is the ratio in which C divides AB over the ratio in which D divides AB. So it's AC on CB over AD on D. Okay. Okay. And notice D is on the outside and C is on the inside. Okay. So if we make this equal to -1, then it makes sense for the ratios to be the same. Yeah. So it divides it externally in the same ratio that divides it internally. So this is the definition of cross ratio here. And when it's equal to -1, that's the definition of harmonic. Okay. And will we even be able to do this today, Alex? So the claim is if you have a pole and a polar, right? That's what we had yesterday. And you take any secant there, yeah? Then these 4 points are harmonic.
Whoa.
Yeah, I don't think we have enough time to get
No,
through
I
this.
don't think we'll have enough time. We kind of need to.
Yeah. Alright, maybe we'll complete this some other time, but that's the goal. And once you got this, we have I don't know if you remember this from the junior book, but we have
Right. The black point.
so it's like the Brocard's. There's a called Brocard's
thing.
thing.
Will form a harmonic quad, right?
Yeah.
We got the. Yeah, it's basically a.
So if you have a cyclic quad and you kind of connect, they're a little bit too close to parallel, but and you join all the vertices up, then so if you remember Brocard's theorem, it was that like the orthocenter of this triangle was like the circumcenter of that circle. Okay. But we're getting a bit more advanced now. We want to say that this line here, so this side of the red triangle, is the polar of this vertex, and the same holds true for every pair of pole and like vertices and it's called a self-polar triangle. So it goes from this to that. Yeah, but we might have to wait.
So for that, the polar, the harmonic one, we kind of just did the Symmedian crap.
Yeah, so this
but
thing.
The problem is, what happens if the pole is inside?
The pole's inside.
Oh.
Oh.
Oh no! What happens if the pole is inside?
Yeah.
I don't know. Maybe we can use like gears to clutch it out if it's inside.
Oh, what if the pole, like it's like that?
Yeah, I don't know. Maybe you can just look here.
Okay, so there's some other thing, like when you have the Symmedian set up, right? And you join this down and it hits the circle somewhere. This thing here is supposed to be harmonic quad. So there's also some definition of like cross ratio for when they're on a circle, not just on a line. And it's supposed to make this equal to -1 on the circle. Okay. Alright, we have to go and break now.
Well, let's see how many hours you got.
Okay.
I am my 5 accounts.
Recording stopped.
Alright, get your shoes on.
Tell me what else.
Yeah, what do you think the bet is? Over 20, under 20?
Let me calculate. How long did that stream go for?
Actually, I think it's gonna be like 36 hours. It's kind of already displayed here.
It's all because of me.
Alright, we'll come back after the break. It'll be like maths physics after the break.
Math physics. Where we'll have the